Good afternoon, everyone. So today we are going to discuss mock test 2, and obviously you can read the instructions from the question paper which will be there. So I'm not repeating the instructions. So let's just begin with the first question. Now he says if x minus 23 into y minus 56 whole divided by x minus 23 whole square plus y minus 56 whole square is equal to minus 1 by 2, then write the value of x plus y. Right? Now, as you can see, I have x minus 23, then I have x minus 23 whole square. Right? Same term is occurring here. And y minus 56, y minus 56 whole square. Right? Rather than writing the same term again and again, what I'll do is I can substitute x minus 23 as A and I can substitute y minus 56 as B. You can make do without substitution also, but I think with substitution you're able to see the solution better. Right, so this becomes A, this is B, so AB, whole divided by, this is A square plus B square. This is equal to minus 1 by 2. Right, if I cross multiply, basically I'll get A plus B whole square. As you can see, why? Because minus A square minus B square, if I shift to this side, so A square plus B square plus 2AB, which is A plus B whole square, which is equal to 0. Right, that means A plus B is equal to 0. Now A was nothing but x minus 23. Plus b, which was nothing but y minus 56. From here you can get the value of x plus y, which turns out to be 79, which is the answer.
In how many ways can a pair of parallel diagonals of a regular polygon, okay, of 8 sides be selected? Parallel diagonals गिननी है, okay, ठीक है, रेगुलर पॉलीगन विद 8 साइड. ऑक्टागन बोल लेते हैं, चलो, बट उन्होंने बोला कि भाई ऑक्टागन नहीं बोलते, कि किसी को ये ना हो कि भाई मेरे से क्वेश्चन इसलिए नहीं हुआ क्योंकि मेरे को वर्ड नहीं पता था. ऑक्टागन, वो चाहते हैं कि आपको चीजें हम दे दें, आप मैथ्स लगाओ. रेगुलर है, सारी साइड्स इक्वल होंगी, ठीक है. मैं इसको मार्क भी कर लेता हूं, ए बी सी डी ई एफ जी एच. कोई भी डबल डायगोनल ना आ जाए, तो इसीलिए मैं मार्किंग कर रहा हूं. I'll start with, मेरे को पेयर ऑफ डायगोनल्स चाहिए, पेयर. जो क्या हो, पैरेलल हो. इससे मतलब है मेरे को, और किसी चीज से मतलब नहीं, ठीक है. सो मैं ए स्टार्टिंग पॉइंट रखता हूं कि ए से डायगोनल कितने बन सकते हैं. ओके, चलो बनाते हैं. ये कॉम्प्लेक्स होता जाएगा तो प्लीज ध्यान से देखना, ठीक है. अगर आप थोड़ा सा ध्यान दो, ए से मैं बी पे भी नहीं बना सकता, एच पे भी नहीं बना सकता डायगोनल, बिकॉज एडजेसेंट है, एडजेसेंट वर्सेस. तो मैं सी पे बना सकता हूं. एक बना, इसके पैरेलल ये होगा और इसके पैरेलल ये होगा. प्रूफ करने की कोई जरूरत नहीं, उसने सिर्फ काउंट करने को बोला और हमें दिखता है इट्स अ रेगुलर हेक्सागन. इसमें नहीं दिख रहा होगा क्योंकि रेगुलर बना नहीं होगा, क्योंकि हर एक साइड इतनी मेजरमेंट से नहीं, देख के बना दी. सो ये सारी लाइंस पैरेलल हैं, ठीक है. ए से पहला बनाया, सो हाउ मेनी पेयर्स, 1 पेयर, फिर 2 पेयर एंड 3 पेयर. मैं लिख देता हूं, आपको पता चल जाएगा. AC is parallel to HD is parallel to GE. So 1, 2 and 3. 3 पेयर्स बन गए, मैंने 3 यहां लिख लिए, ठीक है. अब AD को ज्वाइन करता हूं, ठीक है. ए से ही बना रहा हूं अभी भी, और कहां पे आएगा, यहां से यहां ज्वाइन करना पड़ेगा. तो मेरे पास एक और आया, AD is parallel to HE. भाई जो क्वेश्चन नहीं निकल रहे हैं और आप हिंट ले लेके कर रहे हो, उसको खुद जब तक नहीं करोगे तो नहीं हिलेगा वो क्वेश्चन. फिर से ध्यान से, ठीक है. सो पेयर लिखना है 1 पे. अब ये भी एग्जॉस्ट कर दिया मैंने. अब मैं चलता हूं AE पे. AE पे चला, एक तो उल्टा BD बना और एक बना ये, ठीक है. सो देखो, मैंने AE से शुरू किया था. AE से पहले पीछे आओ BD, और उसके आगे चलो HF. फिर से 3 लिखे हैं, मतलब कि 3 बनेंगे, ठीक है. पेयर कैसे बनता है, 1 पेयर, 2 पेयर, जहां मैं मार्क कर रहा हूं 3 पेयर. 3 पेयर यहां होगा. AE तक चला गया, मैं AF पे भी चला जाता हूं. AF पैरेलल ढूंढना है तो यही होगा, बीई, AF इज पैरेलल टू BE। अभी मैं ए से ही लगा हुआ हूं निकालने के लिए, ठीक है, 1 ये भी हो गया। अगर मैं AG निकाल लूं, ठीक है, तो कौन सा होगा, BF CE, ठीक है। सो मैंने AG से शुरू किया, BF पे बना और CE पे बना। मैं बहुत ध्यान से लिख रहा हूं, ठीक है, बट बाय चांस मिस हो जाए यू कैन टेल मी कि सर आपने एक मिस कर दिया था, ठीक है, 1 2 या 3, और या फिर पैरेलल लाइन के वो इतने सारे हमारे पास ABCDEFGH हैं, शायद गलती ना हो जाए। आई एम ट्राइंग वेरी केयरफुली कि बिल्कुल ठीक से लिखूं, कोई गलती नहीं होनी चाहिए, बट अगर हो जाए डू टेल मी इन द कमेंट्स, कोई प्रॉब्लम नहीं है मुझे, ठीक है। गलती करी है तो ठीक करनी पड़ेगी भाई, ठीक है। सो ए के साथ तो मैंने सारे लिख लिए, अब बी से शुरू हो जाते हैं, ठीक है। ए के साथ कितने बने, 3 9 10 11, 11 तो यहां बन चुके। बी से शुरू हो जाते हैं, बी से सी और ए पे तो जा नहीं सकता, BD बना हुआ है, BE बना हुआ है, मैं BG बना लेता हूं तो CF बन जाएगा। बी से बनाया, BG इज पैरेलल टू CF 1, बाकी तो काउंट कर ही चुका था, BG पे हो गया। अब BH बनाना पड़ेगा, BH बनाया, CG बनाया और FD बनाया, तो मैं यहां पे लिख लेता हूं BH, BH के साथ CG एंड FD या DF व्हाटएवर यू लाइक, 3 यहां। BH तक चला गया तो ये भी सारे एग्जॉस्ट हो गए। C पे चलते हैं, A भी कर चुका, B भी कर चुका, C पे चलो। C D और B के साथ तो बनेगा नहीं, CE बना चुका हूं, CF बना चुका हूं, CG बना चुका हूं, CH नहीं बनाया, ये देखो मिस है, देखा, CH बहुत सारे बन चुके थे, CH एंड GD, CH पैरेलल टू GD, एक ही बना, CA बना चुका हूं, ये भी हो गया। D से DF DG DH DA DB बन चुके हैं सारे, F से भी सारे बन चुके हैं, बाकी सारे काउंट हो चुके हैं, अगर आप देखो सारे डायगोनल्स बना चुके हैं, ठीक है। सो यहां पे मेरे पास 4 बने थे और यहां पे मेरे पास 1 बना, ठीक है, A के साथ, B के साथ एंड C के साथ। तो मैंने ये काउंटिंग करी, ये ऐड करके काउंट किया, ये ऐड। सो 11 + 4 15 एंड 1 16, 16 इज द राइट। ये तो सिर्फ काउंटिंग पे था, ये भी प्रीआरएमओ का क्वेश्चन है, इतना इजी भी आ सकता है, काउंटिंग में अगर गलती करोगे गाइस गड़बड़ है भाई, देन यू आर नॉट स्टडिंग भाई विद द थॉट प्रोसेस, आप सिर्फ बोर्ड की तैयारी कर रहे हो, ठीक है। 11th में हो, योर एम शुड बी जस्ट वन जेई एडवांस, उसी के लिए है ये। बेसिक क्वेश्चन में नहीं लगा पाओगे तो जेई एडवांस के पेपर में कैसे लगा पाओगे? बी वेरी केयरफुल विद दिस, राइट?
Alright, on to the next one. He says the following 4 operations were performed on 2 positive integers. Right? So let me take those positive integers as x and y. Right? Now, he says they were added, so that means it becomes x plus y. Then he says the second operation was the lesser was subtracted from the greater. Right? So obviously I do not know which is the greater or the lesser one. So arbitrarily I can say that x is the greater one. So the lesser was subtracted from the greater, so that means I am talking about x minus y. Right? They were multiplied together, so that means I am talking about x plus. And the larger number was divided by the smaller one, so that is x divided by y. Right? So in each these cases I got these 4 results. He says the results thus obtained were then combined to form a sum of 243. Now these 4 were combined to have the sum of 243. That means this plus this plus this plus this, that is 243. That is 243. Right? Now he says write the sum of 2 positive integers if each is greater than 5. So basically I need to find the values of x and y. Let's see. So I have this equation. So obviously this gets cancelled, I'll get 2x plus xy plus x by y, that is 240. Next step I take LCM and I'll cross multiply y, so I'll get 2xy plus xy square plus x equal to 243y. Right? Now the thing is, how should I proceed further? I have just one equation and I need to find the value of x and y. Mind it, x and y are integers. So that means somehow some factorization should be there, right? Now I can see x is here, x is here, x is here. Let me take x common. Let's see what happens. X common, I'll be left with 2y plus y square plus 1. Wait a second, I'm left with 2y plus y square plus 1. This is a very nice term. Okay, let me rearrange it. Let me write y square plus 2y plus 1. A very nice term. This is nothing but y plus 1 whole square. Right? So left hand side is nothing but x into y plus 1 whole square is equal to 243y. Right? Mind it. Now y will definitely not divide y plus 1 square. Right? Y will divide x. That much I know. So the remaining thing, 243 must divide this one. Right? 243 must divide this one. Mind it, this is y plus 1 whole square. This is a perfect square. 243 is what? 3 raised to 5, right? 3 raised to 5. Now, if this must divide this, what are the possibilities over here? 3 raised to 5 must divide this. So either, since it's a perfect square, maybe it is 3 raised to 2. Maybe it is 3 raised to 4. Right? Now, this must divide this, so either this is the case or this is the case. So let me take both of these cases. Then y plus 1 whole square is equal to 3 square. From here, I'll get y plus 1 is equal to 3 here, and I'll get y is equal to 2. Mind it, he says if each is greater than 5, that means this is greater than 5 and this is greater than 5. Y should be greater than 5 as well. Y is just 2, which is obviously less than 5, so rejected. Second case, y plus 1 whole square, that is equal to 3 raised to 4. From here, I can find that y is nothing but 8. Now, which is greater than 5. Now, if y is 8, I can get the corresponding value of x. X will turn out to be 24. Right? So, he says write the sum of two positive integers. First integer, that is 24. Second integer is 8. I want the sum. That means the answer for this question is 32. Alright, on to the next one. Now, this was one question which was quite easy. So, let's just quickly discuss it. Now, he says let n be an integer equal to this. So, this is nothing but 1 followed by how many zeros? 29 zeros. So, 0, 0, 0, so on, 0, 0. So, these are 29 in number. Right? Minus 30, so subtract 30. Right? So, subtract it. So, here I'll get 0. Then, obviously, I will carry forward. So, this becomes 7. Then, it becomes 9, 9, 9, so on. I'll get it 9. Right? Now, he says let sum of digits of n is k. So, this is my n now. I want sum of the digits. So, I need to basically evaluate how many 9s will come. Right? So, let me see. 9 comes from here and here. Right? 29 zeros were there. 2 I rejected. So, that means 27 zeros are there. 27 9s are there. So, 27 9s. That's it. So, add 9 27 times plus 7, which will give you the answer, and k by 10 turns out to be 25.
Given a circle of radius 188, a regular hexagon and equilateral triangle are inscribed in a circle. जैसे बना हुआ है भाई, ठीक है, बनाया हुआ है already. Write the ratio. Okay, area of a regular hexagon to the area of an equilateral triangle. अब ये क्वेश्चन रेशो का था. आजकल वैसा नहीं आता, बट बहुत पहले हमारे पास ये ऐसी प्रॉब्लम नहीं होती थी. इवन इन द फर्स्ट राउंड आप सीधा आपका सब्जेक्टिव पेपर होता था. अब सारा ऑब्जेक्टिव हो गया है, ठीक है. तो बट पहले नहीं होता था, तो मैंने बहुत पुराना उठाया, ट्राइड, बट मैं ये चाहता था कि बच्चे ऐसा सा क्वेश्चन भी करें, ठीक है. तो इसीलिए ऐसा सा क्वेश्चन डाला, ठीक है. अब अगर आप थोड़ा सा ध्यान दो, अगेन आपको फंसाने के लिए रेडियस 188 दिया हुआ है. अगर रेडियस ना भी दिया होता, सिर्फ आर भी दिया होता, तो भी रेशियो तो निकल ही आती, ठीक है. अब अगर आपने 188 फंसा लिया, लंबा हो जाएगा क्वेश्चन. 188 का स्क्वायर करते रहो, खेलते रहो 188 के साथ, बट मैं 188 के साथ नहीं खेलूंगा, ठीक है. इट्स अ रेगुलर हेक्सागन, ठीक है, और इक्विलेटरल ट्रायंगल बीच में है. तो मेरे को क्या चाहिए? मेरे को ट्रायंगल की साइड चाहिए. ठीक है, बट पहले उससे पहले मैं काम करता हूं, मैं ना सेंटर बना लेता हूं। रेगुलर हेक्सागन है, मतलब कि यहां से लाइन बनाओ, यहां से लाइन बनाओ, यहां से लाइन बनाओ, यहां से लाइन बनाओ, ये सारी छोटी छोटी इक्विलेटरल ट्राइंगल्स ही बनेंगी, ऑल साइड्स आर इक्वल। ठीक है, रेगुलर हेक्सागन का मैंने रेडियस चूज कर लिया था एज आर, मतलब कि ये सब कुछ आर के बराबर है, मतलब कि साइड ऑफ द हेक्सागन इज ऑल्सो आर, सब कुछ आर के हिसाब से चूज किया हुआ है। ठीक है, एंड ऑफ कोर्स दिस इज गोइंग टू बी अ स्ट्रेट लाइन, प्रूव करने की कोई जरूरत नहीं है, रेगुलर हेक्सागन है एंड ऑब्जेक्टिव पेपर है। ठीक है, ऑब्जेक्टिव मींस राइट द आंसर है, शो थोड़ा ना करना है, क्यों करूं मैं इसको प्रूफ। ठीक है, बस मार्किंग कर लेते हैं, इट बिकम्स इजियर फॉर मी। ए बी सी डी, आपको वहां पे मार्किंग करने की भी जरूरत नहीं है, ई एफ सीधा इसी पे ही दिख रहा है, यहीं पे ही सॉल्व कर दो, क्योंकि फिगर पूरी प्रिसाइज बनी हुई थी ऑलरेडी इसके अंदर तो। ठीक है, सो नाउ आई कैन गेट एडी एज, यहां पे साइड पे अपना छोटा सा लिखा, एडी तो 2r के बराबर। ठीक है, मैं क्या यूज करने वाला हूं, अगर वो 2r के बराबर है एंड इट बिकम्स द डायमीटर, मेरे ख्याल से आपको दिख जाना चाहिए था कि ये देखो, अगर वो डायमीटर है तो ये एंगल इन अ सेमी सर्कल बनना चाहिए। देखा, ये एंगल 90 हो, दिख रहा है एंगल 90, एंगल बी। आपको एडी 2r दिया हुआ है और एबी r दिया हुआ है, कांट यू यूज पाइथागोरस थ्योरम एंड फाइंड बीडी? बिल्कुल निकलेगा भाई, एबी स्क्वायर प्लस बीडी स्क्वायर इज इक्वल टू एडी स्क्वायर। एबी कितना है, आर का स्क्वायर, बीडी कितना है निकालना है भाई वो तो, एडी कितना है 2r का स्क्वायर। सो मेरे ख्याल से मेरे पास बीडी स्क्वायर कम्स आउट टू बी 3r स्क्वायर एंड बीडी कम्स आउट टू बी रूट 3r। बीडी आपके पास रूट 3r आ गया। अब इतना ज्यादा सिंपल हो चुका है क्वेश्चन, क्योंकि एरिया ऑफ एन इक्विलेटरल ट्राइंगल मैं सीधा निकाल सकता हूं, रूट 3/4 रूट 3/4 3r स्क्वायर, डायरेक्टली लिखो यार। ठीक है, सो 3√3/4 r स्क्वायर, एक चीज तो मिल चुकी है। अब रह गया हेक्सागन का। हेक्सागन अगर आप ध्यान दो, ये छोटी छोटी इक्विलेटरल ट्राइंगल से ही बना है, दिख रही है इक्विलेटरल ट्राइंगल छोटी छोटी, कितनी ऐसी इक्विलेटरल ट्राइंगल, 6 इक्विलेटरल ट्राइंगल है। सो एरिया ऑफ HEX लिख लेता हूं, हेक्सागन 6 इक्विलेटरल ट्राइंगल्स, √3/4 a स्क्वायर, a मींस r का स्क्वायर, तो 2 यहां पे 3 आ गया, 3√3/2 r स्क्वायर। रेशियो की बात करी उसने, ऊपर हेक्सागन रखना था 3√3/4 ना बाय 2 r स्क्वायर, और नीचे रखा 3√3/4 r स्क्वायर, तो दिख रहा था कैंसिल है। इसको थोड़ा सा ठीक करके लिख लेता हूं, वैसे तो आप डायरेक्टली काट सकते थे, हायर क्लासेस में तो होगा, मैं 9th वालों के लिए कर रहा हूं कि अगर आपने गलती कर दी तो पता तो चले गलती कहां है। ये कैंसिल हो गया, ये 2 टाइम्स, आंसर इज 2/1, मतलब कि 2 रेशियो, दिस इज योर आंसर। ठीक है,
Now he says write the number of two-digit possibilities. Two-digit possibilities. So that means I need to consider only from 10 to 99. But there's a condition that is divisible by both of their digits. So let me just consider the first of which is, now the digits are 1 and 0 obviously. Now let me see whether 10 is divisible by 1, obviously. Then 10 divisible by 0, not a chance. So that means I will not consider 10. Next, let me consider 11. Now 11 is divisible by 1, divisible by 1, so yes. Then let's take 12. Divisible by 1, divisible by 2, yes. 13, divisible by 1, not divisible by 3, no. Then 14, divisible by 1, not divisible by 4, so no. Then 15, divisible by 1, 5, yes. 16, no, because not divisible by 6. Then 17, of course not. Then 18, of course not. 19, not a chance. 20, not even considered. Then 21, no. 22, yes. Then 23, no. 24, yes. Divisible by 2, divisible by 4, that is why. Just exhaust the cases and you will get the answer as 14.
Means Parikshit was born in the year between 1300 and 1400. And there was another person called Bhaskar who was born in the year between 1400 and 1500. Each was born on 6th April. Okay? And the year was a perfect square. Excellent. They both lived for 110 years. बाप रे, बहुत ज्यादा जी है भाई ये तो. ठीक है. Write the sum of digits of the year के sum of digits लिखने हैं, in which they both were alive होने चाहिए, and also their ages were perfect square. ठीक है. On April 7. ठीक है. So there are two persons. One is Parikshit, P लिख रहा हूं मैं, and one is Bhaskar. ठीक है. अब सबसे पहले मेरे को यह निकालना है कि परीक्षित वॉज बॉर्न इन द ईयर बिटवीन 1300 एंड 1400 एंड इसके बीच में मेरे को क्या ढूंढना है? परफेक्ट स्क्वायर. मेरे ख्याल से इट वॉज क्वाइट सिंपल. 1369, राइट? 1369 इज अ परफेक्ट स्क्वायर इन बिटवीन दैट. ठीक है. ऐसे ही भास्कर कौन से ईयर में बॉर्न हुआ? परफेक्ट स्क्वायर होना चाहिए 1400 और 1500 में. मेरे ख्याल से सबने ये निकाल लिया होगा. दैट इज 1444. ठीक है. क्वाइट स्ट्रेट फॉरवर्ड, इसमें कुछ ज्यादा दिक्कत नहीं. ठीक है. नाउ दे वर अलाइव. ठीक है. कौन से ईयर से कौन से ईयर तक दे वर अलाइव वो निकालना है सबसे पहले. सो परीक्षित वाज बोर्न इन द ईयर 1369 एंड ही वाज अलाइव फॉर 110 years, मींस 1479 तक वो अलाइव था. 110 years. ठीक है. भास्कर वाज बोर्न इन द ईयर 1444. ठीक है. And was alive for 110 years, so ये आ जाएगा 1554. ठीक है. 110 years, ये सारी चीजें मैंने लिख ली जो उसने पहले बार बोला था. Sum of digits of the year in which they both were alive. तो सबसे पहले तो both alive वाला ईयर निकाल. Both alive. ठीक है. So कॉमन पार्ट निकालना है. ठीक है. 1369 से 1479, बट ये पैदा ही 1444 में हुआ, तो मतलब कि मेरे को ये ड्यूरेशन पता चल गई. कौन सी है? दे बोथ वर अलाइव फ्रॉम 1444 टू 1479. 1444 में भास्कर पैदा हुआ एंड परीक्षित डाइड इन द ईयर 1479. सो दे वर अलाइव इसके बीच में. ठीक है. अब इसके अंदर मेरे को चेक करना है कि दोनों की एज परफेक्ट स्क्वायर होनी चाहिए. ठीक है. नेक्स्ट पेज पे चलते हैं. यहां पे हम बना ही लेंगे 1444 टू 1479. ठीक है. पहले मैं लिखता हूं परीक्षित. परीक्षित वाज बोर्न अर्लियर, तो परीक्षित को पहले लिखा एंड फिर लिखा भास्कर, और यहां पे मैं लिख लेता हूं ईयर कौन सा चल. ठीक है. सो 1444 नहीं, 1445 से शुरू करेंगे बिकॉज भास्कर वाज 1. ठीक है. एंड परीक्षित वॉज, सब्ट्रैक्ट करोगे आपको आराम से पता चल जाएगा कि भाई भास्कर ना परीक्षित वॉज 76 years ऑफ एज. दोनों की एज परफेक्ट स्क्वायर होनी चाहिए. ओके. तो बेस्ट इज भास्कर की एज परफेक्ट स्क्वायर पे निकाल लेते हैं. ठीक है. भास्कर परफेक्ट स्क्वायर मेरे पास है, परीक्षित परफेक्ट स्क्वायर नहीं है, तो ये तो नहीं उठाऊं. अब नेक्स्ट परफेक्ट स्क्वायर ऑफ भास्कर कब आएगी? एट द एज ऑफ 4. ठीक है. सो एट द एज ऑफ 4 अगर मैंने यहां पे ऐड किया तो 76 से तो आपका जो परीक्षित है वुड बी 79 years ऑफ एज. मेरे को ईयर लिखने की जरूरत ही नहीं है अभी, तो ये परफेक्ट स्क्वायर है, ये परफेक्ट स्क्वायर नहीं है. नेक्स्ट परफेक्ट स्क्वायर इज 9. सब्ट्रैक्ट करा, 8 आया यार, 8 ऐड कर दिया दूसरे में, आपको सीधा दिखेगा ही वुड बी ऑफ 84 years ऑफ एज. ये परफेक्ट स्क्वायर है, ये नहीं है. ठीक है. फिर 16 आएगा, 16 years of age. सब्ट्रैक्ट किया, 15 आया, तो 76 में 15 ऐड किया, दैट वुड बी 91. अगेन ये परफेक्ट स्क्वायर नहीं है. ठीक है. ये परफेक्ट स्क्वायर है. भास्कर वाज अब 25 पे परफेक्ट स्क्वायर आएगा उसका. एज 25 इज अ परफेक्ट स्क्वायर. ठीक है. अब 25 मतलब कि मैंने सब्ट्रैक्ट किया, 25 माइनस 1 दैट इज 24, तो 76 में मैंने 24 ऐड किया, दैट वुड बी 100 years. ये भी परफेक्ट स्क्वायर आ गया. बस दैट्स इट. तो 24 ऐड कर देना है मेरे को, और कुछ भी नहीं करना. जैसे 24 ऐड किया इसके अंदर सीधा. ठीक है. 24 ऐड किया, मेरे पास आ जाएगा 1469। ठीक है, सो इन ईयर 1469 हमारे पास क्या था? परीक्षित वाज 100 इयर्स ऑफ एज, भास्कर वाज 25 इयर्स ऑफ एज। जो कंडीशन लगाई थी वो मेरे को मिल गई। 1469 वाज द ईयर एंड सम ऑफ डिजिट्स करना है 1 + 4 + 6 + 9। तो द सम इज, दैट्स इट। इतना सा क्वेश्चन था, सोचो समझो और लगा दो। मेरे ख्याल से दैट वाज क्वाइट स्ट्रेट फॉरवर्ड एंड होना चाहिए था। 9th वाले बच्चे भी इजीली इसको अटेम्प्ट कर सकते हैं। It was not a tough one, guys. ठीक है, let's move on to the next question.
Now he says let alpha be the number of all quadratic polynomials of this form. Right? Now it is a quadratic polynomial, that means leading coefficients have to be non-zero. So a is not equal to 0. And my form is ax square plus bx plus c. Now he says where ABC comes from this collection 0, 1, 2, 3, 4, 5. Right? So that means A, of course it can't be 0, it can be 1, 2, 3, 4, 5. B, it can be 0, 1, 2, 3, 4, 5. And similarly with C. Right? And he says this condition needs to be satisfied. That means B square greater than equal to AC. Right? We need to find the value of alpha minus 30. Basically, I need to find how many number of quadratic polynomials are there. Right? Now, if I can find out the different values of A, B, C, I can have the different polynomials, right? So, I need to know in how many different ways can I have A, B, and C, right? Which satisfy this condition as well as this condition. Now, obviously, we'll start with this condition, B square greater than equal to AC. I can rewrite this AC less than equal to B square. Cool? Because I am more comfortable with this equation, less than equal to. Right? Now, I can see B is either 0 or 1 or 2, 3, 4, 5. So, let me make the cases. Then B is equal to 0. Right? AC is obviously less than equal to 0. Now, I need to find out the values, the corresponding values of A and C. Right? The least value of A which is possible. Obviously, 0 is not possible. 1. So, let's start with 1. Corresponding to A is equal to 1, I need to check out the values of C. Now, do you think I can put C as 0? Yes, 1 and 2 0, that is 0, which is obviously less than equal to 0, right? Then, you think I can put C as 1? No. Then 1 into 1, that becomes 1, 1 less than equal to 0. Anyways, he says that AC should less than equal to 0, right? Less than 0 as in negative. A and C are positive numbers, right? Obviously, it cannot be negative. That means the minimum value, the only value it can attain, that is 0. So, product of two quantities is 0. Either one has to be A has to be 0 or C has to be 0. A cannot be 0, so we started with C. Right? Now, A is equal to 1, exhaustive. Now, A is equal to 2. We can take that. Now, C has to be 0. Right? 2, 1, 2, 2, none of those satisfies. So, that means now A can be 3, so 3, 0. Then A can be 4, 4, 0, 5. So, from here, I get 5 polynomials. Why? Because A is equal to 1, B is equal to 0, C is equal to 0. That gives me 1 polynomial. So, I can see the different number of solutions over here will give me different polynomials that I am interested in. Right? Okay. Now, next one, when B is equal to 1. So, AC is less than equal to 1. Right? Now, I know that AC is a whole number. So, either it can be 0 or it can be 1. Less than equal to 1. Right? 0 wale case is already likhe humne 1 0. Now, mind it, I will not write it like 1 0 2 0. What I'll do is I will keep A as 1 and exhaust all the possibilities when A is equal to 1, so that I do not miss out anything. Right? So, when A is 1, C can be 0. When A is 1, C can be 1. It's satisfied. When A is 1, C can be 2. No, this doesn't satisfy. Right? So, 1 2 doesn't satisfy. 1 3 will not satisfy. 1 4, so 1 5, yeah. 1 1. A is equal to 1, exhausted. Now, 2 0, satisfied. 2 1, absolutely not. Right? 2 2, obviously not, and so on. Then 3 0, yes. 3 1, no. 4 0, yes. 5 0, yes. Done? So, from here, obviously, I am getting 6. Right? Let me do one more. So, B is equal to 2. That means AC is less than equal to 4. Right? So, let's start with A is equal to 1. So, 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, absolutely not. Right? Then let's move on to 2 1. So, 2 0, 2 1, 2 2, yes. 2 3, no. 2 4, obviously no. Moving on. Then A is equal to 3, so 3 0, 3 1. 3 2, no. Then 4 0, 4 1, yes. Then obviously 4 2 will not come, then 5 0, and that is the end of it. Now these are 13 in number, right? So on similar lines, you can find when B is equal to 3, AC less than equal to 9. You just need to find the solutions. Provided you move in a systematic manner, the answer should be there, right? This is 5, 6, 13. For this one, it turns out to be 20. From B is equal to 4, AC less than equal to 16, we get 27, right? Then B is equal to 5, that means AC less than equal to 25, we get 30. Right? On similar lines, you can do that. So in total, how many polynomials? This plus this plus this plus this plus this plus this. This turned out to be 101. So that means alpha is 101. But you don't want alpha, you want alpha minus 30. That is why the answer is 71. Alright, on to the next one. Now he says rectangle ABCD has length AB as 4 and length BC as 6. Now he says semicircle with diameter AE and FC. So semicircle 1, semicircle 2. Obviously center is S and C. It has radius R each. Radius R, radius R. Now he says they touch each other at P, already marked. Write the value of 6R. So I am interested in the radius of these two semicircles. Right? Now obviously these two circles are touching externally. Now, whenever touching externally, what I'll do is I will join the point of contact with this center. And if I extend it, I know that this will pass in the other center. So this form a straight line. So I will probably be using it. Also, I can see that this length is R. So that means this total length is 2R. Cool. Now, if I want to find out R, so I would want to use this as the side of a triangle in order to set up equations. Now, if I want to use this, I need to use this 4. Also, this is a rectangle, right? So that means 90 degrees here. And somehow I need to use 90 degrees, but I want this as the side of the triangle. So what I'll do is I will draw the perpendicular. Right? So if I call this point Q. This length and this length is same. So this is 4, this is 4. Right? So I'll be working in this triangle SQT. I know this length I know in terms of R. Somehow if I am able to find this length QT in terms of R, my problem is solved. I know this entire length 6, right? I am interested in this one. Let me see whether I can find the remaining portion or not. What is this length? Now this length is nothing but R, right? So R. Now I am interested in this, but I know this remaining part. Somehow if I know this remaining part, my problem is solved. Now this remaining part is nothing but R again. So this is 6, this is R, this is R. That means this length is 6 minus 2R. Done? I think my equation is set up because Pythagoras theorem, I will just say 4 square plus 6 minus 2R whole square is equal to 2R whole square. Just solve it for R and you will find the value of 6R to be 13, which is the answer. Alright, on to the next one. Now he says the radius of the circle is 8. Angle AOB, as in this angle, is equal to BOC, as in this angle, is equal to COD, as in this angle, is equal to AOD. Now, if these 4 angles are equal, that means each angle is equal to 90 degrees. So this is 90, this is 90. Maybe I can use it. Now, he says that AO is 24, right? I want to find DS. That means I want to find out this. Now, mind it, D is a point outside the circle. Right? DS is a tangent. And from the same point, I have DT, which is the tangent. Obviously, DS will be equal to DT. So, instead of finding out DS, I will find out DT. Why? Because AO is given over here, so maybe DT I can find out faster. Right? Now, obviously, tangent is given, I can join the point of contact with the center, and this angle is 90 degrees. Right? I am interested in this length. Okay. Now, the thing is, what all lengths I know already. So, this is radius, this is A. This is 24, this is 90, this is 8. So that means this length is nothing but 16 root 2. Right? I want to find out this length. Mind it, here it is 90 degree, here it is 90 degree. Right? Using similarity of this triangle and the bigger triangle. Right? I can write the statement that OT square is nothing but 80 into dt. You can easily write it, and in fact, we do remember the result. We have done this question so many times in class 9. Right? So OT square is obviously nothing but A square is equal to 16 root 2 into dt. You can find out the value of dt, which turns out to be 4 by root 2. Right? That means dt is this, so that means ds is this. Now, he says you need to find out 5 root 2 into ds. Just substitute it and your answer will be 20. Alright, on to the next question. Now he says let n be this. With the smallest positive integer where a, b, c are primes. Obviously, supposedly I have written prime factorization, and this is the smallest positive integer. But it should satisfy the condition. N by 6 is a perfect cube. Now n by 6, that means it has to be a whole number. So n should be divisible by 2 and 3. Right? So that means 2 of the primes I can ascertain. They have to be 2 and then it has to be 3. Also n by 10 is a perfect fifth part. That means n should be divisible by 10. That means n should be divisible by 2 as well as 9. So that means I don't know the 3 prime numbers. So 2 is there, suppose, q is there, 3 is there, and then 5 is there. Alright, similarly I will write this as 3 into 5. Right? Let me tell you the first condition. Now it says n by 2 into 3. Now let me just write n by 2 into 3. I can rewrite this as 2 raised to power p minus 1 into 3 raised to power q minus 1 into 5 raised to power 1. Is that fine? I've just substituted the value of n from here to here. Now he says this number, as in this number is a perfect cube. Now I know if the number is a perfect cube, so that means this has to be divisible by 3, so it has to be 3, 6, 9 and so on. Similarly 3, 6, 9 and so on, 3, 6, 9 and so on. Right? Now, if p minus 1 is 3, that means the value of p is 4. If p minus 1 is 6, the value of p is 7. Then next is 9, so here it is 10. So I will just write the corresponding values of p. So I get either 4, 7, 10 and so on. Similarly, when I talk about q, I know that q minus 1 is either 3, 6, 9 and so on. Similarly, q I will get 4, 7, 10 and so on. And r, you will just directly say 3, 6, 9 and so on. Right? Now, on to the next condition. Now he says n by 2 into 3. So again, I will rewrite this. So 2 raised to power p minus 1 into 3 raised to power q into 5 raised to power r minus 1. Now this has to be perfect fifth part. So that means p minus 1 can be 5, then it can be 10, then 15 and so on. So that means p will turn out to be 6, 11, 16 and so on. Q has no restriction, so it will be 5, 10, 15 and so on. Then R again it will be 6, 11, 16 and so on. Right? Similarly, you will write for n by 3 into 5 and you will say 3 raised to power, I should write 2, 1. So 2 raised to power p into 3 raised to power q minus 1 into 5 raised to power r minus 1. Now this has to be a perfect square. P is 2, 4, 6 and so on. Q minus 1. If it is 2, then that means q is 3. Q minus 1. If it is 4, then q is 5. So 3, 5, 7 and so on. And r will go on the same. Right? Now you need to find p, q and r which satisfy this condition, this condition, this condition. And that to the smallest one. So just look for the smallest one. So I can see, in fact you can search it out, I will directly write it. P actually turns out to be 16. Because 16 will be present over here if I write 13, 16. Right, 16 is present over here and obviously these are all even, so 16 will be present over here. And similarly you will find that Q turns out to be 25. Just search for it, the smallest number will be present over here, over here, over here. And R turns out to be 21. Right? You can add them up. P plus Q plus R turns out to be 62, but he says product of digits. So 6 into 2, that is why the answer is 12. Alright, on to the next one. Now he says in a motorcycle competition, one of the 3 motorcycles that started out at the same time. So 3 motorcycles are there, first, second and third. And they are starting at the same time. Now he says one of the motorcycles was doing 15 km less than the first one and 3 km more than the third one. Right? So that means he's talking about this one. Right? Since he's talking about this With regard to this, I'm talking about this, and with regard to this, I'm talking about this. So let me consider this as the primary one, right? Now, so maybe I can say that this person covers X kilometer. Now he says this is 15 kilometers less than the first one. That means the first one is traveling 15 kilometers more, so it should be X plus 15, right? And 3 kilometers more than the third one. That means this one is moving less, right? So that means this is X minus 3. Right? Now he says they arrived at the terminal point where they ends, obviously where the race ends, 12 minutes after the first machine. Right? So that means time after the 12 minutes after the first one and 3 minutes after the third one. Okay. He says there are no stops en route. Write the length of the course in kilometer. Right? Now suppose the length of the course is d. Right? I want to find out the value of d. Now I know distances. I know the condition related to time. That means I will form my equation involving time. Right? Now, let me write the time taken first. Now, if the distance is this, and we have, if the distance to be covered up is this, and this is kind of the speed, which says x plus 15. So this, time taken would be d divided by x plus 15. Right? Now, here the time would be d by x. Here the time would be d by x minus 3. Right? So, because I am talking about x plus 15 in 1 hour. So, maybe I am talking about the speed. Here I am talking about x kilometer in 1 hour. So, I am talking about speed. Here x minus 3 in 1 hour. So, I am talking about the speed. Right? So, distance by speed will obviously give me time. Now, he says the second one arrives 12 minutes after the first one. Right? That means he took more time. So, we will say d by x minus d by x plus 15. That is 12 minutes. Mind it, we take the speed in kilometer per hour. So, that means I need to write 12 minutes in terms of hour. So, that is 12 by 60. First equation. Right? Second. He says the second one again is he arrives 3 minutes after the third one. Right? So, that means again he is taking more time. So, that means d by x minus d by x minus 3. Right? Now, this is 3 minutes, but I need to convert it into hours, so that is 3 by 60. Right? So, I have two variables, two equations. I can easily solve it. How? I can see that d can be taken out common over here, d can be taken out common over here. If I divide the two equations, d would be cancelled out. That means I will get a quadratic in x. Right? Divide the two equations, you get a quadratic in x. Right? But we are not interested in the value of x. We are interested in the value of d. So, once you find x, you can find d. Right? And distance turns out to be 90 kilometers in this case. That is why the answer is 9. Let's move on to the next one. Now, he says for how many positive integers k? So, k is a positive integer. Do the lines with equations this and this intersect at a point whose coordinates are positive integers. Now, I want to find the point of intersection. Obviously, point of intersection comes when we take the two equations simultaneously, right? When we solve them simultaneously. Now, mind it, k has to be an integer. Also, the solutions have to be integers. In fact, they have to be positive integers. All of these, this is a positive integer, positive integer, positive integer, positive integer, positive integer. Right? Now, my equation is 9x plus 4y equal to 600. And the other one is kx minus 4y equal to 20. Now, what is that one very tempting thing to do over here? Right? Now, 4y minus 4y. Obviously, I would like to add the equation. So, this becomes 9 plus k into x. That is 624. So, x turns out to be 624 divided by k plus 9. Right? Mind it that x is a positive integer. That means this have to be an integer. That means 624 have to be completely divisible by k plus 9. Right? Also, k itself is a positive integer. That means k plus 9 is, maybe it is 10, maybe it is 11, maybe it is 12, and so on. Right? So, I can just look for the factors or divisors of 624. Mind it, those factors which are greater than 9. Right? So, obviously, the first factor would be 12. And the next factor, we can write it like this. Yes, the next factor can be 13, then 26, The corresponding values. Now we are talking about 624 factors of 624. Yeah, 12, 13, then we have 16, then 24, and then we can list out. There aren't many factors by the way. But, we can further reduce the problem. Why? Because, look, I have just talked about X. I can talk about Y as well. From here, I can write Y as 600 minus 9x divided by 6, which is nothing but 150 minus 9x by 4. Now, if this has to be an integer, obviously this is an integer, this has to be an integer, right? That means x needs to be divisible by 4. X needs to be divisible by 4. X needs to be divisible by 4. Now, this is already divisible by 4, right? So that means this factor has to be such that my 4 factor doesn't cancel out. So, definitely it cannot be a factor like 30, right? Have to be careful of that. Now, we can just list out the factors. So, we have 12, 13, 16, 24 and the last factor is obviously 624. We can find out the corresponding value of x, we can find out the corresponding value of y, right? And there are hardly any cases, they just turn out to be 7, right? That is why there are 7 positive integers k, for which x and y also are positive integers. On to the next question. Now he says if f of x be a polynomial of lowest degree with rational coefficients, lowest degree and rational coefficients, of which one root is given to be this. The better word should have been 0, but it's fine. You get the gist of it, right? So lowest degree polynomial with rational coefficients and 1 0 is given to be that. Suppose the coefficient of the linear term is minus 18, then write the numerical value of the constant term of f of x. If I'm able to write the polynomial f of x, I can write the constant term and the numerical value, right? Now, let's just study. One root is this, and I want a polynomial with rational coefficients, right? So, if I'm considering my polynomial in x, I know one value of x is nothing but cube root of 3 plus 2 into cube root of 9. Right? Using this, I need to make a polynomial with rational coefficients. That means radical sign should not be there. Now, radical sign, I want to remove it. And obviously, let me see. I cannot leave it like this. Radical signs are there. If I square it up, radical sign will not disappear because I want to get rid of cube root. If I want to get rid of cube root, that means I need to cube it. So, I can do that. X cube is equal to cube root of 3 plus 2 into cube root of 9 whole cube. Right? Because clearly, if x is equal to this, x also satisfies this equation. Right? So, a plus b whole cube, I can write it. So, that is a cube, which is 3, plus b cube, which is 2 into cube root of 9 whole cube. So, 2 cube, that is 8. 8 into 9, that is 72, plus 3ab. So, ab. So, multiply that. So, cube root of 3 into 2 into cube root of 9 into a plus b. Right? 3ab into a plus b. Now, a plus b, you have substituted as x. Right? This is equal to x cube. If you simplify it, you will get x cube minus 18x plus 7 minus 75, that is equal to 0. Right? The polynomial f of x is this one. X cube minus 18 minus 75. Right? Lowest degree polynomial, rational coefficients, and obviously one of the root is this. Right? Now he says, write the numerical value of the constant term. Constant term is what? Minus 75. I just want the numerical value, as in the number associated with it, which is 75, which is the answer. Alright, on to the next one. Line segments AC and DF are tangents to the circle at B and E. You can see tangents. If also AF intersects the circle at P and R and intersects BE at Q, right? If angle CECAF, so that means this angle is given to be 40 degree, and DFA, so that means this tiny angle, that is 30, and FPE, where is F? FPE, that means this angle, that is equal to be 25. I am interested in PEQ, that means this angle. Right, this tiny angle I am interested in. Now, obviously, since tangents are given, that means I will locate my center. Maybe it is here. And if I join the point of contact with the center, I know that this angle is 90. And if I join this, I know that this entire angle is 90 degrees. Right? Now, let me just try to write all the angles that I can figure it out. Now, mind it, this angle is 90, so this is 90. So, move to this triangle. FE, I don't know this, maybe we can use it F. FES triangle. This is 90, this is 30. That means this angle is 60 degrees. Right? Alright. What else? I found out one angle, which is this one. Now, this is the vertically opposite angle, so that means this is 60. Right? What else do I know? Now, mind it, if I consider this quadrilateral, OSAB. Can you see the quadrilateral? OSAB. Now, it is a quadrilateral, that means sum, as in this, plus this, plus this, plus this, that is 360. Now, this is 60, this is 40, this is 90. I can find out this angle, that turns out to be 170. Right? Mind it, I have to go to this tiny triangle. Okay, tiny angle, not triangle. Tiny angle. How should I go? How should I move on? Now, consider this triangle, OEB. Triangle OEB. Can you find out some other angle? I think you can. In this triangle OEB, OE is equal to OB. Right? It is an isosceles triangle. This is 170. That means this angle plus this angle, this one. These two angles, the sum is what? That is 10 degrees. So each will be 5. So that means this is 5 degrees and this angle, this is 5. Right? Okay. Now, which angle? Maybe I should write it here. Angle BES, that is 5 degrees. This is it. Right? I am interested in this angle, this one. Now, move to this triangle, triangle PES. Let me make it for you so that it is easier. Triangle PES. So, I know that this is S, this is P, this is E. This angle is 60 degrees. I am recreating it. And I am interested in this angle, EQS. So, I am interested in this angle. I already know that this is 5. And this is 25, which I have not used till now. Mind it, this, as you can see, is the exterior angle of triangle PES. Exterior angle is equal to sum of this and this. This is 60, this is 25, so that means this is 35. This entire angle. Out of this entire angle, this is 5. That means this angle is 30 degrees, which is angle PEQ. That is why the answer is 30. Next one. Now he says a 3-digit number ABC is called virtual prime. 3-digit number ABC is a virtual prime when if one obtains a 2-digit prime number by changing at most one of its units or 10th digits B and C. Right? Okay. So I don't understand this, but he has given us an example. He says 318 is a virtual prime because 17 is prime. Okay, let me just analyze this. Now 318. Obviously this is a 3-digit number. Now he says it is a virtual prime. That means I can obtain a 2-digit prime number. 2-digit prime number. So maybe I can have 11, maybe I can have 23, maybe I can have 73 and so on. Right? By changing at most one of its units or 10th digits B and C. So unit is 8, obviously 10 is 1, right? By changing at most one of these, at most, right? So either I can change none of these or I can change one of these, right? Not both, because he says at most one, right? Okay. So now 1, 8. Now if I need to change one digit, which digit? He says you can change 8 to 7, right? 1 has, and we know that 17 is a prime. If that is the case, that means such kind of number will be called a virtual prime. Right? Okay. Now he says that alpha be the number of such virtual primes. You need to find the value of alpha by 81. So basically I need to find alpha. Right? Okay. So basically I need to have 3-digit number. Now 3-digit number. Mind that there is no restriction on the first digit. Right? We do not care about the first digit at all. Right? So maybe I can put in 0. Careful. It's a 3-digit number. Obviously, I cannot put in 0. That means either I can put in 1, 2, 3, 4, so on till 9. Right? I have 9 possibilities for the first one. Right? So I can fill the first place in 9. Right? Now, corresponding to this, I need to define this. Now, this is the tricky part. Now, he says you should have a 2-digit prime number by changing at most one of its unit or 10th digit. Right? I should get a 2-digit prime number. My 2-digit prime numbers look like, let's start with 11. Right? I have 11, I have 13, I have 17, I have 19, and so on. Mind it, 11, 13, 17, 19. Suppose I take the number 10. Right? That's the least 2-digit number that I can think of, right? Now, if I'm taking 10, maybe I can change 0 to 1. If I change 0 to 1, I'll get the number 11, which is the prime number. That means I need to consider the number 10. Right? What about number 11? The next 2-digit number, 11. I can take that. It itself is a prime. I don't need to change anything. Right? Next is 12. Mind it, obviously 12 is not a prime number, but I can change 2 to 3 maybe, or maybe 1, whatever you will like it, right? If I change this number to 3, this becomes 13, which is a prime number. That means I will take 12. Obviously, I'll take 13. Again, 14 again, because I can change 4 to 1, 3, 9, whatever you like it, right? So I'll take 14. I'll take 15. I'll take 16, 17, 18, 19. Done? So 10 to 19, all of these 2 digits came. Okay, where are you? Let me think about the 20 is like that. Now, prime number 20, that is 23, then we have 29. Right? Let's start with, suppose we have moved on to 29. Now, let's talk about 20. If I replace 0 with 3, I'll get 23. Right? So, I'm getting a 2-digit prime number, so that means I'll take 20. 21. If I replace 1 with 3, again I'll get 23. That means if I take any number from 20 to 29, I can get either, I can make this or this. Right? Done? Now, let's talk about the next prime number, which is 31. And then we have 37. Right? So, again, I will cover up all the numbers from 30 to 39. Right? Similarly, I will cover all of the numbers from 40 to 49. Right? Because I can change one of the digits and I will get 41. Similarly, 50 to 59, 60 to 69, all of the 2-digit numbers are covered up. You take any 2 digits. You just need to change one of its digits and you'll get a prime number. Right? Because in all the tests from 11 to 20, right, you have a prime number. From 21 to 29, you have a prime number. From 30 to 39, you have a prime number. Right? So in chunks of 10, you have a prime number anyways. So that means any 2-digit number you take, you will get a virtual prime. How many 2 digits are there? 2-digit numbers? From 10 to 99, how many 2-digit numbers are there? 90. Right? So that means I can have 90 possibilities for both of these cases. Right? 90 possibilities. Now, obviously, since I know corresponding to each choice over here I have 90, here I have 9 choices. So in total, I had 9 into 93 choices, which is nothing but 810. This is the number of virtual primes. That is alpha. But I don't want alpha. I want alpha by 81. So divide by 81. Right? The answer is obviously in this case 10. Now, he says the product of 7 and the 6-digit number A, B, C, D, E, F. So he is talking about product of 2 quantities. One quantity is 7, right? And the other quantity is 6-digit number A, B, C, D, E, F. 7 into A, B, C, D, E, F. Right? So obviously I can see this is the first digit, second, third, fourth, fifth, sixth, or if you want to start from here, same thing. Now he says this product, and this into this, is actually equal to the product of 6 and the 6-digit number D, E, F, A, B, C. Right? So this product is again actually equal to product of 2 quantities. First one is what? 6 into, now the second 6-digit number, that is D, E, F, A, B, C. Right? You can see this is a 6-digit number. Now he says if this is the case, then write the sum of the digits of the smaller of the 2 6-digit numbers. Now, which 2 6-digit numbers is he talking about? First one is this and second one is this. He says you need to write the sum of the digits of the smaller of the 2. So you need to determine which is the smaller one. Now I can say which is the smaller one provided I know the number, provided I know the number. So basically all I need to do is find out the value of A, B, C, D, F. Now maybe I can find the value individually or as a chunk maybe I can get the value, right? So I have this condition. Using this condition I need to proceed further. Now product of two quantities. Now you will say, ma'am, just multiply the two. Now the thing is, since I don't know these digits, it will be difficult to multiply 7 with it, right? If I want to multiply the number, how can I proceed when I don't know the digits? I can go for the expanded form. Now you can say, ma'am, you can write this number in the expanded form as A into 10 raised to power 5 plus B into 10 raised to power 4 plus C into 10 raised to power 3 plus D into 10 square plus E into 10 raised to power 1 plus F. Right? This is the expanded form of this one. Mind it, I can do this the same thing on the right hand side as well. But is there a better way to write the expanded form? Mind it, just look at the two numbers. First number is obviously this one, second one is this. Now you can see that this is a chunk of the number, this is the chunk of the number. Right? Chunk, chunk. As you can see, ABC is present in both of these. So ABC as a unit is present in both of these. And I'm not interchanging any of these numbers. So rather than writing the expanded form like this, what I'll do is, I will make use of this fact that I have ABC over here, I have ABC over here. I will write the expanded form as ABC, I will not touch it because it's already there, ABC, into, obviously that is 10 cube, plus DEF, again I will not change it because I need that chunk, so DEF. Right, I'll multiply 7 with this. I will write the expanded form of this number in this way. Cool. On the similar lines I can do on the right hand side. 6 into, now this becomes DEF into 10 cube plus 8. Right. Now mind it, I can write it 7 into 1000 into ABC. Now ABC, DEF, it is occurring again and again. What I can do is I can just replace it or substitute it. So let ABC be X and DEF be Y. So that it is a bit easier for me to see it. Now, obviously, I can see that X is a 3-digit number and Y is a 3-digit number, right? So this becomes 7 into, this is nothing but 1000X plus Y is equal to 6 into, this becomes 1000Y plus X, right? I will obviously combine the like terms and ultimately I will get 538X equal to 461Y. Right? This is a prime number. This can be written as 2 into 269. 269 is again a prime number. Right? Now, I need to solve this equation. I need to find the value of X and Y. Because if I know X and Y, basically I know this 3-digit number, I know this 3-digit number. So that means I know the number. Now, mind it, I know that 461 is a prime number. 461 will definitely not divide this one. Cool? Right. So that means 461 must divide X. Now, 461 must divide X, that means either X can be 461 or its multiple. Now, I know that 461 is I know that X is a 3-digit number, right? So, there are hardly any possibilities. First possibility I'll take when 461 divides X, so that means let me take X as 461. Right? On similar lines, obviously 538 will not divide 461. It has to divide X. It has to divide Y. Right? Again, Y is a 3-digit number. That means hardly any possibility. In fact, just one possibility. That means Y has to be 538. No other possibility is there in fact. Right? So my numbers actually are nothing but one number is 461 and 538. Right? Second number is 538 and 461. Right, my 6-digit number. Now, which is the smaller of the two? Obviously, this one. Right? You can just add the digits and you will get the answer as 27, which is the correct answer. Alright, on to the next one. Now, he says if polynomials this and this have 3 common zeros, then write the value of this combination. Now, obviously, if I can find out A, B, and C, my problem will be solved. Now, where is A? A is here, B is here, and C is here. Now, the condition given to us is polynomials have 3 common zeros. Mind it, this is a cubic polynomial, right? It will have 3 zeros anyway. And Leading coefficient 1, leading coefficient 1. That means what? The factors must be like x minus alpha into x minus beta into x minus gamma. Right? And obviously zeros are alpha, beta, gamma. Now we know they have three common zeros. That means alpha, beta, gamma must be zeros of this polynomial. That means it will also have a factor of x minus alpha, x minus beta into x minus gamma and additional linear factors. Right? Mind it, these factors are already present over here. Can you see what is happening between the two polynomials? Right? We can clearly see that this polynomial will be exactly divisible by this one. Right? Because all of these factors are coming in the factorization of this. So this polynomial is divisible by this. Alright. So x raised to power 4 minus 12x cubed plus bx square plus 216x plus c is exactly divisible by this. So one way is I can obviously divide it properly, or I can just write it like this. I know that this is the dividend, so my divisor is that x cubed plus ax square minus 18x plus 90. Now there would be some questions, right? Now obviously this question have to be a linear factor, x cubed x raised to 4. So that means this has to be x, right? Up. Now I need linear factors, so that means I need the constant term. Mind it, here the constant term is c. Right? C. So obviously I would not want to write the constant term as C by 9. Why? Because fraction gets involved and we are not a big fan of fraction. So what I'll do is let the constant term be k, whatever the case may be. Yeah, we introduce one variable ourselves, it's okay, we'll find out the value of that one. Big deal. Right? Plus remainder of exactly divisible, so that means remainder is 0. Now, we know that this is a polynomial, this is a polynomial. Left hand side, right hand side polynomial. That means this corresponding coefficient should be equal. Now, obviously, the coefficient of x raised to 4 is 1. Coefficient of x raised to 4 is 1. Obviously, there is no condition there. Now, let's talk about coefficient of x cubed, which is minus 1. Right? Coefficient of x cubed. Now, mind it, we'll start with this one. X cubed should be multiplied by k in order to get the coefficient of x cubed, right? So that means here I'll get k. Then, let me see whether I can have x cubed from here or not. X square x. I will get x cubed. That means the coefficient is a. So, k plus a is my coefficient of x cubed on the right hand side. Done? Now, let's move on to x square. The coefficient of x square is b. Now, coefficient of x square. Obviously, I will not start with x cubed. I will start with x square. Now, this will need to be multiplied by the constant term. So, that is ak. Then, this one. This needs to be multiplied here. So, that means minus 18. This cannot be multiplied by anything. So, it's okay. Second relation I got. Right? Now, coefficient of x, which is 216, is equal to. Coefficient of x, I will not get from here. I will not get from here. Maybe I can get it from here. So, that is minus 18k. Plus, anything else from here? Yes, coefficient of x, so that means plus 90. Cool? Done. And last, obviously the constant term. Now, he says constant term is c. Here the constant term is 90k. Right? Using 4 relations, 4 variables are there. Let me find out the value. First of all, obviously I can see that k will turn out to be 7. Now, k turns out to be 7, that means c turns out to be, k turns out to be minus 7. Here it is plus 90 or minus 90. Okay, wait. K turn out to be 7. Then, this is 90k, that is C. C turn out to be 630. Minus 90k क्यों आ रहा है मेरा? ये कैसे हुआ? Minus 90k के लिखा. K is actually turning out to be minus 7 from here. Yes. C will turn out to be minus 630. Perfect. B. Right. Now, instead of finding out B, I'll find out A. So, substitute K as minus 7. This will turn out to be minus 5. Substitute A and K over here, you will get B, which will turn out to be 70. You know the value of A, you know the value of B, you know the value of C. Just substitute it here and you will get the answer as 30. Alright, the next one. Now it says write the number of integral solution of it. Now, integral solution of it. Now, y quadratic in x and then quadratic in y, right? So I do not know how to solve the equation as this, but he says you don't need to talk about all the solutions, just the integral solution, right? Now if I look carefully on left hand side, I can see the factors as y into y plus 1. Why are we going for the factors? Any solving of the equation requires factorization, right? So whatever I can factorize, I will factorize. On left hand side, if I take x common, and that will be left with 1 plus x square plus x cube. Again, this is factorizable. This is 1 plus x into 1 plus x square. Right? So I have these 9 factors. Now integral solution. First of all, let me write the obvious one, right? Which will make left hand side equal to right hand side. Obviously, which will be, I will try to make this as 0 and this as 0. Now, if I put y as 0, right, y as 0, so this becomes 1, nobody cares. Now x will be, I can put x as 0 or I can put x as minus 1 also. Why? Because if I put x as minus 1, this term becomes 0. So I can do this also. Right? Now taken y as 0. Now if I want to make this as 0, I can put y as minus 1 also. So if I put y as minus 1, this thing becomes 0, nobody cares about this. This is minus 1, we care. Right? Now, right hand side 0, so obviously I can put x as 0, 1 case, or I can put as x as minus. Right? The obvious one, so I can put. Now the problem is, what about the non-obvious one? Let's see. So y into y plus 1 equal to x into 1 plus x into 1 plus x. Now, if I want to look ahead, what I can do? Maybe I can put x as 1. Let me see solutions in positive integers first. So if I'm putting x as 1, okay, 1 into 2 into 3, right? Into 2 in fact. Yeah. And this is y into y plus 1. Now, the thing is, this is 4. Can you think of splitting 4 as product of 2 integers and 2 consecutive integers? I can't do that because 4 I'll write. I'm just talking about the positive one. 1 into 4 or 2 into 2. Again, positive consecutive integers are not there. So this is not there. Then I can put x equal to 2. If I put x equal to 2, y into y plus 1 is 5. This becomes 2 into 3 into 5. Now this is a nice thing. Why? Because this is 30. 30 I can write as 5 into 6. Right? So if I do that, I get x as 2. Along with that, I get y as 5. Or the second case is y as 9. Yes. Right? Again, the obvious one I'm getting. Now, next, let's move ahead. X equal to 3. Y into y plus 1. This becomes 3 into 4 into 10. Now, if you look carefully, here consecutive integers are there. And this number is 12 and this number is 10. Right? No, not product of consecutive integers, so I will reject it. Now, when I put x equal to 4, this becomes 4 into 5 into 17. So, this is 20, this is 17. Again, product of not 2 consecutive integers. In fact, the difference between 20 and 17 is 3. Alright, not the 1. X equal to 5. Then I write 5 into 6 into 26. Now, 30, 26. In fact, if you notice, here consecutive integers are not there. In fact, the difference is 2. Then the difference is 3. Then the difference is 4. And if you go forward, you can see that the difference is increasing. So that means the nearest 2 factors, in fact, they are going apart from each other. So that means ahead I may not get any solution. Now you can say, what about in the negative integer side? You can do that. Now x equal to minus 1, I've already written. X equal to minus 2. Right? If I do that, x equal to minus 2, y into minus 1, as it is equal to. This is minus 2. This is minus 1, which becomes positive in fact, but okay, fine. And this becomes 5. Again, the problem is the same. Here I have 2 into 5, 10. Again, I cannot write it. Then I put x equal to minus 3. So y into y plus 1 minus 3. So minus 3. Then I will do minus 2 and then I will do 10. Again, that is 60, 60. The nearest one is in fact 10 into 6. 10 into 6. Again, you can see here the difference was 3, here the difference is 4. It will keep on increasing. The nearest two factors will have difference increasing. I will not get the product as two consecutive numbers. Right? So that means the only possible solutions are these. And the answer is 0. Alright. For the next question, the figure is given to us. Now he says angle P is 90, PQ is 24, and PR is 32. Now since I know it's a right angle triangle, I know the third side, which turns out to be 40. Right? Even if you do not know the Pythagorean triplet, you can see that this is 8 into 3, this is 8 into 4, this has to be 8 into 5. Right? Next thing he says M is the midpoint of RQ. That means this is equal to this. So dia is 40, that means this is 20, this is 20. Now he says NM is perpendicular to RQ, so this is 90. We are interested in the area of this triangle, PNQ. This is a very special type of triangle. Why? Because it is a right angle triangle. The area for right angle triangle is nothing but half base. I can take PQ as a base into height. With regards to PQ as a base, my height would be PN. Right? Now I already know PQ, which is 24. Right? All I need to do is find out the value of PN. Right? Okay. Now PN is this length. In order to find out this one, I know that this is a right triangle. Right? That means if somehow I get to know this side using Pythagoras theorem, I can find out this one. That means I want NQ now. Mind it, NQ is also involved in some other right angle triangle, which is this one, NQ. Right? If I want to find out this value, this already I know, that means I want to know N. Right? Now, in order to find NM, I need to think about it. Now, NM is involved in this triangle, NRM. Right? What is so special about this tiny triangle? Right? Obviously 90 degrees is there. Also, it shares an angle with the bigger triangle. Right? 90, 90. Shares an angle. That means this triangle is similar to the big one. Right? Maybe I can use this. Now, let me write the similarity statement. So, triangle, I'll start with M because 90 degrees. MRN is similar to triangle. Now, corresponding to M, it has to be P, then R, then Q. Right? Now, I am interested in NM, so that means this one. So, MN divided by PQ, PQ. Do I know the length PQ, which is 24? Yes. Is equal to. Now, which length do I know? RN? No, I do not know. MR? Yes, I know. So, I will use this MR by PR. MR is nothing but 20 divided by PR, which is 30. Right? From here, you can get the value of MN, which is nothing but 15. Right? Now, this is 15. My job is done. Why? This is 15, this is 20. That means this is 25. So, I can shift it. Now, this is 24, this is 25. That means this is 7. Done? Just substitute it and you will get the answer as 84. Alright, now we are moving on to the next question. Now he says, let PQR be an acute angle triangle in which SCU are points on QR, RC, PQ respectively, such that PS is perpendicular to QR, PT is equal to TR, RU bisects angle R. Obviously, let's just try to make the figure first. So, my acute angle triangle, PQR. PQR. Now, he says that PS is perpendicular to QR. So, top to perpendicular here. Now, PT is equal to TR, so T is here. This is equal to this. And RU bisects angle R internally. Right? RU, so this point is U. And this angle is equal to this one. Now, he says joint ST. So, joint. Now, M is the intersection of PS and RU. So, this point is M. And N is the intersection of ST and RU. Done. Now, he says that MU is 2. MR is 3. Okay. Right. I think I missed one thing. PM is given to be equal to 4. MS is 2. And it should be given MN turns out to be 1. I think it's written in the question paper. I have not written it here, right? Okay. So M is 1. Now, he says write the value of root 3 into area of triangle PQR. So, in short, I am interested in the area of the triangle, right? Now, first of all, if I am interested in the area, let me just see what kind of a triangle is it, right? Okay, so let's just look at that. Now, C I know is the midpoint of CR, right? Also, if I look carefully, this is this is 2, this is 1. That means this entire length is 3. Now, this is 3 and this is 3. Now, can you say that N is the midpoint of RU? N midpoint of RU. Right? First point of observation. Right? This is the midpoint, this is the midpoint. And there is a line joining the midpoint. So, consider this triangle PRU. In triangle PRU, I have a line joining the midpoints of the two sides. That means this line would be parallel to the third side. So this is parallel to this. So NT parallel to UT. NT parallel to UT. Right? Now this is a very kind inference now. Right? Now this is parallel to this. Now NT, if I extend this line is nothing but extension of NT, right? So that means this line is parallel to this line. Right? Now if this is parallel to this, come to the bigger triangle PRQ. In triangle PRQ, T is the midpoint and this is the line parallel to this side. That means it will bisect the third side. That means S has to be the midpoint and QS will be equal to SR. QS will be equal to SR. Right? This is the converse of midpoint theorem. Right? Okay. Now, what else? Now, this is the midpoint. S is the midpoint, so here we are. Now, if you come back to this, because यहाँ पे 90 degree था, and this length is equal to this length, यहाँ पे 90 degree है, can I say the triangle PQS is congruent to triangle PRS? Triangle PQS is congruent to triangle PRS. Right? Obviously, if these two triangles are congruent, that means PQ will be equal to PR. PQ will be equal to PR. So that means the triangle that I am talking about, it is an isosceles triangle. Mind it. Okay, so I know how to find the area of isosceles triangle. But first, let me just figure it out whether it is a nicer triangle or not. Because I have not utilized the fact that there is a what? There is an angle bisector right over here. Now, let's see. Angle bisector. इसका use करना है? इसका use कैसे करें? Now, this length is equal to, this angle is equal to this angle. And we have established that S is the midpoint over here. Now mind it, in triangle PQR, this is the midpoint and I have this thing. What can you call PS as? PS is the median, right? This is the median, okay, right. It is a median. Now, there is a point on this median, right, M. And I know that PM is equal to 4 and M is equal to 2. PM is 4 and MS is equal to 2. That means the ratio is what? 4 by 2. M is the point which divides the median in the ratio 4:2. Or in short, 2:1. There is a point on the median which divides the median in the ratio 2:1. That means this is a very special point. This point is nothing but the centroid of the triangle. Right? Observation number 3, I guess now. Now, M is the centroid. Now, in the triangle, if M is the centroid, that means RU is not only the angle bisector, it is also the median because it is passing through the centroid. Now, if RU is the median, that means I have established that this length PU is equal to UQ. Again, this angle is equal to this angle. This is the common side. This is equal to this. Can I say that triangle PRU is congruent to QRQ? Right? If those two triangles are congruent, that means PR is equal to QR. Very nice. That means PQ is equal to PR is equal to QR. All the three sides are equal. That means it is a very nice triangle. It is an equilateral triangle. right? You can easily find the area of equilateral triangle, not a big deal. I know that equilateral triangle area is root 3 by 4 into side square. Side square I can find out. Why? Because I know the height, right? You can take your side to be 2x, right? That means this length is x, right? This is 6 which is given to you. Now this is also the side, that means this is 2x again. Just apply the values here, or people who know trigonometry, they can use that and you will get the answer. And the answer will actually turn out to be 36. Alright, on to the next one. An inverted right circular cone of height 25 centimeter is filled with oil up to half of its height. First of all, I am talking about the inverted cone. So it looks something like this. It is half filled with oil. This looks like an inverted cone? Yes. First of all, height is 25. Half filled is filled with water up to half its height. So this is my oil. And suppose this height has to be 25 by 2. Right, the oil is dripping from a hole in the tip. So obviously oil is leaking out from here, as you can see. Initially, the upper surface area of the oil. Initially, upper surface area. Where is the oil? Oil is here. What is the upper surface area? Oil is here. Upper surface area is this one. This area is given to be what? 154 centimeters square. Right? Okay, let's move on. Now he says after 49 minutes, since the oil is coming out, the height of the oil becomes half of its original height. So after 49 minutes, half of its original one. So now my oil is here. Right? This height is 25 by 4. Why? Half of this. That is 25 by 4. And now he says the upper surface area. So oil is here, upper surface area is this one. This is how much? This is 77 by 2. And this all happens in 49 minutes. Now what happens? Oil from a cylindrical beaker of diameter this and height this is poured into the cone. In how many more minutes will the cone be emptied out? Right? Now, if I need to empty out the cone, I need to empty out this oil which is left and the additional oil that I poured. Right? Okay. Now what do I know? That what happened? The oil which leaked out, which is this one, in 49 minutes. So, how much volume of oil dripped out in 49 minutes? Let me find out. So this is the volume of the oil, right? This is nothing but the volume of the bigger cone minus volume of this red cone, right? The volume of the bigger cone. So I know that is 1 by 3 pi r square h. Now pi r square, because this is the area of the circle which is given to you, that is 154, right? Into h, height is 25 by 2 minus the volume of the smaller cone, which is 1 by 3 into. Now, this area is already given, so 77 by 2 into the height, which is 25 by 4. Right? This much volume was dripped out, or it was let out in 49 minutes. Right? Now, how much volume has to go in order to empty out the cone? First of all, this much volume. So, this is what? Volume of this cone, which is nothing but 1 by 3 into 77 by 2 into 25 by 4. Right? Plus the additional oil that I poured from the cylindrical beaker. Now, volume of the oil in the cylinder would be equal to the volume of the cylinder. So, plus additional oil that I need to empty it out. Volume of the cylinder, which is pi, 22 by 7, into r, which is diameter is 3.5, r is 3.5 by 2, r square 50.5 by 2 again, into height, which is 25. Right? Now, it took 49 minutes to empty out this. I need to empty out this much of water, oil, right? So, as you can see, this and this, they are directly proportional, right? This and this, they will be directly proportional, right? Or I can say, this is in direct variation or this is in direct variation. So, this thing divided by this is equal to this time I need to find out. This by this is equal to this by this. You can see the rate at which it is being emptied out is uniform. That is why I am saying it is in direct variation. Right? So you can find out, you can consider this to be x. You just need to divide it. You are brilliant at calculations, hopefully. And the answer turns out to be 28. Alright, on to the next one. Now he says if n is the number of positive integers less than 1000 that contain at least one 1, right? At least one should be there. At least one should be there. So that means I can have maybe just 1 1. Maybe I can have 2 1, right? Then I can have 3 1. Do you think I can have 4 1? No, I want less than 1000. So either I have a 1-digit number or a 2-digit number or a 3-digit number, right? Now, in their decimal representation, then write the value of zint of n by 4, where obviously zint of x is the greatest integer less than or equal to n, right? Fine. This I'll figure out later on. First of all, I am interested in the value of n, right? N is the number of positive integers less than 1000 which contain at least one 1, right? Now, the thing is, I need to consider this case when it has exactly 1. Right? When it has exactly 2 and when it has exactly 3. Right? I have 3 different cases. Mind it, there is just one case left. Since all I am interested in 1-digit number or 2-digit number or 3-digit number, only one case is there which is left, which is when ones are not there, when there is no ones in the decimal expansion, in the decimal representation. Right? Now, don't you think this is much easier to find out? If I can find out this, right, I'll subtract this from the entire numbers. Now, he says numbers less than 1000, so that means I'm considering the numbers from what? 1, 2, so on to 999. How many numbers are there? 999. From this, if I subtract these numbers, I will satisfy the condition. Now, he says 1 should not be there. Now, first of all, let me consider the 1-digit number. 1, right? So maybe I can 0, obviously not. 1, obviously not. 2, 3, so on till 9. So that means I will have 8 numbers, right? 2-digit number. Not right. 2-digit number. Mind it, 1 should not be there. Now, first thing, obviously I cannot put in 0 over here or 1 over here. That means I can fill this place in 8 different. Corresponding to this, in how many ways can I fill this one? I cannot put 1 now. Right? Except for 1, I can have maybe 0, I can have 2, I can have 5. So that means I have 9 possibilities. Right? Now, corresponding to each choice over here, 9 choices were there. Right? Now, it has 8 choices. That means in total, I have 8 into 9. Which is, you can find out which is 70. Right? Now, third case, 3-digit number. 1 should not be present. Now, first case, 0 cannot be there, 1 should not be there. So that means 8 ways. Corresponding to this, 1 cannot be there, that means 9 ways. Corresponding to this, 1 should not be there, 9 ways. In total, it should be 8 into 9 into 9, which actually turns out to be 648. Right? So, these, how many these are numbers? These are in total 728 in number. These are the numbers that I do not want. If I don't want these numbers, I can subtract it from my 999. Right? This will turn out to be 271. That means in total 271 positive integers are there less than 1000 which contain at least 1 1. Right? That means n turns out to be 6. But I don't want n. I want n by 4. First of all, n by 4. So that means 271 by 4. That is 67 point something. Right? Now he says I need to find out the greatest integer less than or equal to x. Now this is 67 point something, less than integer source tab. 67, then I have 66, then I have 65 and so on. Right? It is greatest among these, which is 67. That is why the answer for this question is 67.
क्वेश्चन नंबर थ्योरी का क्वेश्चन है, ज्यादा मुश्किल नहीं है. नंबर थ्योरी के क्वेश्चन सारे समझने वाले होते हैं और स्टेप बाय स्टेप लगाओ. ठीक है. A 4-digit number ABCD is said to be faulty if it has the following property. Product of last 2 digits is equal to a 2-digit number AB, while the product of these two is equal to 2-digit number B. Write the sum of digits of all faulty numbers. 4-digit number है मेरे पास A, B, C, D. ठीक है. product of last two digits, okay, C into D is equal to a two digit number AB. टू डिजिट नंबर AB की बात करिए उसने, राइट? टू डिजिट नंबर AB, सो 10A plus B, ठीक है? While the product of these two numbers C minus 1 into D minus 1 is equal to a two digit number again 10B plus A. अभी तो मैंने सिर्फ इक्वेशंस लिखी हैं, ठीक है? जो उसने बोला वो लिख दिया. डिस्ट्रीब्यूटिव लगाओ, CD minus C minus D plus 1 is equal to 10B plus A. CD की वैल्यू पुट कर सकता हूं मैं ऊपर से, 10A plus B minus C minus D plus 1 is equal to 10B plus A. इस पूरे को मैं इधर ले जाता हूं, इस पूरे को मैं इधर, ठीक है? कंबाइन हो जाएगा, देखते हैं क्या बनता है. 10A minus A, that is 9A, ठीक है? और ये B है, ये 10B है, तो minus 9B plus 1 is equal to C plus D. ये बन गया. सो 9 कॉमन लिया, A minus B plus 1 is equal to C plus D, right? C plus D. 9 times A minus B plus 1 is equal to C plus D. अब कैसे चले? E, B, C, D, चार चार वेरिएबल, इक्वेशन एक ही है, मैं पुट भी किसको करना शुरू करूं? ठीक है, सम ऑफ डिजिट्स. सम ऑफ डिजिट्स से जल्दी निकल सकता है, ठीक है? सम ऑफ डिजिट्स पे चलते हैं. तो मैं A प्लस बी को एक बार अगर आप ध्यान दोगे, A माइनस बी को, सॉरी, ठीक है? तो C प्लस D कैन बी रिटन एज ऑफ द फॉर्म 9K प्लस 1, ठीक है? 9K प्लस 1 है, 9 इंटू समथिंग प्लस 1 है, तो 9K प्लस 1 फॉर्म है, यूक्लिड डिवीजन लेमा लगाया, ठीक है? मुझे ये क्यों कर पाया? A इज एन इंटीजर, B इज एन इंटीजर, दोनों को माइनस किया तो भी वो इंटीजर ही रहेगा ना, और कुछ तो नहीं बन सकता, ठीक है? तो इसलिए मैंने सीधा का सीधा उसको लिख दिया, ठीक है? अब ये इंटीजर बन गया, 9K प्लस 1 फॉर्म आ गया. K की वैल्यू पुट करनी पड़ेगी, ठीक है? मैं यहां पे लिखता हूं C प्लस D इज इक्वल टू 9K प्लस 1, ठीक है? केसेस बनाते हैं. K is 0, C plus D is 1, and K is 1, so C plus D is 10. K is 2, तो 18, हाँ, C plus D 19 हो जाएगा, 18 plus 1, ठीक है? 19. Sum of digits cannot be 19, ठीक है? तो मेरे पास दो ही केसेस बनते हैं, तो C plus D के साथ दो केसेस बन रहे हैं, तो मैं पहला केस लिख लेता हूं यहां पे, ठीक है? केस नंबर 1, ये यहां पे ऐसे बनेगा, ठीक है? सो केस नंबर 1 कैसे बनेगा? C plus D is given to be 1, ओके? तो मैं C को लिख सकता हूं, क्या लिख सकता हूं? C को मैं 0 लिख सकता हूं, D को 1 लिख सकता हूं, या फिर C को 1 लिख सकता हूं, D को 0 लिख सकता हूं, ठीक है? मुझे एक इक्वेशन भी दी हुई है, क्या दिया हुआ था? C इंटू D इज इक्वल टू 10, क्या था? 10A प्लस B, ये दिया हुआ, ठीक है? 10A प्लस D, ठीक है? तो अगर मैंने C इंटू D इसके केस में लिया, 0 बन रहा है, दूसरे के केस में लिया तो भी 0 बन रहा है. भाई ये टू डिजिट नंबर रहेगा? बोलो नो. ये टू डिजिट नंबर रहेगा? नो, ठीक है? टू डिजिट नंबर, सो नो केसेस. इससे तो कोई केस नहीं बनता. पार्ट 2 पे चलते हैं. केस नंबर 2, व्हेन K इज 1. मेरे को पता चल गया C प्लस D इज इक्वल टू 10. मैं C से शुरू करता हूं. C कैन बी 1, D कैन बी 9, C कैन बी 2, D कैन बी 8, C कैन बी 3, D कैन बी 7, C कैन बी 4, D कैन बी 6, C कैन बी 5, D कैन बी 5, C कैन बी 6, D कैन बी 4, C कैन बी, बढ़ा दो उसको, 7, D कैन बी 3, C is 8, D is 2 and C is 9 is 1। ठीक है, ये केसेस बने मेरे पास सी और डी में। ठीक है, अब मेनली मेरे को एक चीज देखनी है कि भाई मेरे पास एक इक्वेशन दी हुई थी, दैट इज, एक मिनट, ए की वैल्यू 1 डाली थी ना, ए की वैल्यू 1 डाली, तो ए माइनस बी भी तो 1 है, ए माइनस बी भी 1 है। एक केसेस यहां बने क्योंकि के इज 1, ए माइनस बी भी 1 नहीं होगा। ए माइनस बी 1 कैसे बनेगा भाई? 1 माइनस 0 से बन सकता है, 2 माइनस 1 से बन सकता है, 3 माइनस 2 से बन सकता है। देखो अलग अलग केसेस बन रहे हैं। 4 माइनस 3 से बन सकता है, 5 माइनस 4, 6 माइनस 5, 7 माइनस 6, 8 माइनस 7, 9 माइनस 8। तभी हर एक केस में ये 1 बन। ठीक है, मैंने सी प्लस डी के भी केसेस लिख लिए, ए माइनस बी के भी केसेस लिख लिए। कंडीशन तो मेरे को एक चाहिए जिससे मैं चेक करूंगा कि कौन सा केस वैलिड है। सी माइनस डी इज इक्वल टू 10a प्लस बी। ठीक है, 10a प्लस बी। अब मैंने फर्स्ट केस लिया, इसको लिया 1, इसको लिया 9, 2 डिजिट नंबर ही नहीं बन रहा, कहानी खत्म हो गई। ठीक है, फिर मैंने इसको लिया 2, इसको लिया 8, प्रोडक्ट किया, आया मेरे पास 16। ठीक है, प्रोडक्ट किया 16 बना, मेरे को इधर भी तो 16 बनाना पड़ेगा। 10a प्लस बी पे भी 16 बनाना है। 10a प्लस बी पे 16 कैसे बनेगा? अगर मैं 1 डालता हूं एक ही जगह, ठीक है, एक ही जगह मैंने 1 डाला, तो बी की जगह मेरे को 0 डालना पड़ेगा, मेरा 16 नहीं बन रहा। कोई नहीं, नेक्स्ट वाले पे चलते हैं। 3 इंटू 7, ठीक है, सी की जगह 3, डी की जगह 7, तो ये मेरे पास आ गया 21। ऑल गुड, 21 बना। अब 21 बनाने के लिए ए को मेरे को 2 लेना पड़ेगा और बी को मेरे को 1 लेना पड़ेगा। क्या 2 और 1 है कंडीशन? यस है। तो मतलब कि C3 D7 एंड A2 B1 इट इज अ केस। ये केस है मेरे पास, मैंने अलग करके लिख लिया। इस केस को कहीं लिखूं, यहां लिख देता हूं, 2 1 3 7, ABCD के ऑर्डर में लिखना था ना, लिख लिया एक केस। चलो नेक्स्ट वन, C is 4, D is 6, 24 बनाना है। मतलब कि C की वैल्यू ना, A की वैल्यू मेरे को 2 चाहिए, B की वैल्यू मेरे को 4 चाहिए। ठीक है, तभी मेरे पास 24 बनेगा। 2 and 4 आ रहा है कहीं पे? नॉट एट ऑल, 2 and 4 का कोई केस नहीं है मेरे पास। ठीक है, इसके बाद चलते हैं 5 and 5 पे, दैट इज गोइंग टू बी 25। तो मतलब कि मेरे को A 2 ही चाहिए, B 5 चाहिए। कोई केस है जिसमें A 2 और B 5 आ रहा है इकट्ठा? नो। चलो वापस चलो आगे, 6 and 4, दैट इज गोइंग टू बी 24। ओके, 24 तो अभी चेक किया था, बन ही नहीं रहा। चलो ओके, इसके बाद चलते हैं 7 and 3 पे। C is 7, D is 3, 21 का तो केस दिख रहा था मेरे को, अभी तो किया है। ऊपर देख लो, A is 2, B is 1, और वो वाला केस है हमारे पास। पेज क्यों चला जाता भाई ये? ठीक है, तो इसको और इसको मिला के नंबर बन सकता है, दैट वुड बी 2173। ठीक है, 2 नंबर्स बन चुके हैं मेरे पास। ठीक है, तो इसके बाद चलो 8 and 2, दैट इज 16। यार 16 अभी ऊपर चेक तो किया है। A has to be 1, B has to be 0, A has to be 1, B 0 नहीं, तो सॉरी, वो उस टाइम पे मैंने वैसे चूज किया था। 16 के लिए A 1 और B मेरे को चाहिए 6, मेरे को यहाँ पे भी ठीक कर लेना चाहिए। ठीक है, और ऐसा कोई केस नहीं है, मैंने उसको कहा, मैंने उसको वहां पे देखा था कि मेरे पास वो वाला केस है, तो उससे तो आंसर आ गया। ठीक है, तो हम चेकिंग को बेटर कर लेते हैं ना। 9 इंटू 1, 9 इंटू 1 9 बनता है, तो ये तो 2 डिजिट नंबर ही नहीं है। देयर आर ओनली 2 नंबर्स, इनका सम ऑफ डिजिट्स चाहिए। ओके, 2 प्लस 1 प्लस 3 प्लस 7, तो ये कितना बना? 10, 13। यहां से भी 13 बन रहा है, सम ऑफ डिजिट्स यहां से भी 13 बन रहा है, दोनों का सम ऑफ डिजिट्स ऐड कर दिया, आंसर इज 26। ये अब एक नंबर थ्योरी का क्वेश्चन है जिसमें आपको सोच के काम करना था। इजी क्वेश्चन नहीं था, मैं सीरियसली बोलूं तो दिखने में इजी है कि बस इतना ही करना था, बट स्टेप्स थे इसके अंदर, ब्रेक डाउन करना था प्रॉब्लम को, इट वुड टेक टाइम। ऐसे नहीं होगा ये सॉल्व. इट्स नॉट दैट सिंपल. यू हैव टू रिवाइज इट अगेन एंड अगेन कि भाई कैसे सोचा गया. ठीक है.
All right, on to the next one. Now he says A, B, C, D is a rectangle inscribed in a circle. Obviously, center is O. Now he says that AB is greater than BC. I've tried to make that. The ratio of the area of circle to the area of rectangle is pi to 3. And then angle ODC as in this angle is equal to ADE as in this angle. Then he says write the value of AD by AE is 1. So AD is here, AE is here. Also I know that this is a rectangle, so 90 degrees. I might be able to use that. Now the main condition is this: ratio of area of circle to the area of rectangle. Now obviously the area of circle is 5 r square. So I'm obviously considering the radius to be r. Right? Now area of rectangle, if I consider this to be A and this to be B, I know that the area of rectangle is A. Now he says this ratio is nothing but pi by root. Right? So obviously I will get this cancelled out and I will get AB is equal to root 3, one relation. Right? Also I know that this is a rectangle, right? So here I have 90 degrees. Right? Now if I extend this is the diameter, DB is the diameter as well as DB is the diagonal of the rectangle, right? I might be able to use that because this is A, this is B and this length will be 2r. So using Pythagoras theorem I can say that A square plus B square equal to 2r whole square which is 4r. I have this condition, I have this condition. Cool. So what I'll do is I will take the value of r square from here and will substitute here and I will get r square is nothing but AB by root 3. So I am getting this equation root 3 A square minus 4AB minus root 3 B square plus root 3 B square equal to 0. Done. Now if I notice carefully, I know the factors of this equation. Why? I need to think of splitting minus 4 in two numbers such that the sum is minus 4 and the product is 3. That I can do as minus 3AB and minus AB. That is not a big deal. For splitting the middle term, you will get the factors as root 3A minus B into A minus root 3B. That is equal to 0. Now, so obviously root 3A is equal to B or the other case is A is equal to root 3B. Now, he did say that AB is greater than BC. So that means A is greater. If A is greater, obviously I will reject this and because A is the greater one, right? So the question is that was not the thing. I was interested in AB by A. Till now we have not used the fact that these two angles are equal. Now equality of angles, where do I use it? Either I use it in congruent triangles or similar triangles. Obviously I am not able to see congruent triangles with similar triangles are very clear to us. If I consider this triangle ADE. Why? Because anyways AD by AE, I would be using this triangle. This triangle is similar to this triangle, the big one. The two angles are equal 90. And this big triangle gives me the ratio A by B. Right? Gives me the ratio AD by AE. No? Right. Okay. Let me just write it, the similarity statement. So I can write triangle CDB is similar to CA, so triangle A, and for D I will go with D, so this is ADE. Just write the similarity statement and also you already know this ratio A by B which is equal to root 3. You will get AD by AE as root 3 raised to 4, the answer is 0.9. Alright, on to the next one. Now he says a positive integer n with n greater than or equal to is called a Nella number. If there exists a positive integer x, where x is less than n, and there exists a positive n such that two conditions, right? Two conditions are m is not divisible by x and by x plus 1. M is not divisible by x and m is not divisible by x plus 1. Okay. Second condition, m is divisible by every other positive integer from 1 to n, both included. It should be divisible by every other. That means except for x and x plus 1, it should be divisible by every other positive integer. right? Now when I read this statement, I am unable to understand it better. What I can do is, he says that n is equal to 7 is a Nella number. Let me just analyze it. How this n is equal to 7 is a Nella number? Let me check. Right? N is a positive number greater than or equal to 3. So n is equal to 7. I can say this is a Nella number if there exists. That means I need to show an existence of a positive integer x. I need to show that there is a number x. Now, x should be less than n. That means x should be less than 7. Now, x less than 7. That means possible values of x. 1, 2, 3, 4, 5, 6. Done? Right? I need to show the existence of this. And there should exist a positive integer m. Such that, up two conditions are there. M is not divisible by x and x plus 1. X and x plus 1. Right? Okay. And the second condition, m is divisible by every other. Right? This is a condition that I need to check. Now, hardly x has any possibilities. Let me check. X equal to 1. Let me see whether x equal to 1 satisfies the thing or not. Now, he says m should not be divisible by x, as in not be divisible by 1, and x plus 1, not divisible by 2. Okay? Should not be divisible by 1, not divisible by 2. But m should be divisible by every other. That means, except for 1 and 2, every other. 3, 4, 5, 6, up from 1 to n. So 1 is obviously rejected here. N, that means 7. Now you need to find m which is not divisible by 1 and not divisible by 2, but should be divisible by 3, 4, 5, 6, 7. Any number which is divisible by 3 would be divisible by 1, right? So that means you are unable to find m. That means x equal to 1 is not my existence number. Right? Let's move on. X equal to 2. Fine. Right? That means I need to find m which is not divisible by 2 and not divisible by 3. Cool. But it should be divisible by every other. That means m should be divisible by 1, leave 2, leave 3, 4, 5, 6, 7. Now wait a second. M should be divisible by 4, right? Any number which is divisible by 4 will be divisible by 2. Contradiction. That means there is no m. That means x cannot be 2. Rejected? So, let's see what happens when x equals to 3. Right? Now, m should be such that it should not be divisible by 3, it should not be divisible by 4. But it should be divisible by every other positive integer. That means m should be divisible by 1, 2, 3, 4 more, 5, 6, 7. Now, mind it, m is divisible by 6. Any number which is divisible by 6 is obviously divisible by 3. That means you are unable to find m. That means x cannot be 3. Now, x equal to 4. M should be such that it should not be divisible by 4 and it should not be divisible by 5. But m should be divisible by 1, 2, 3, 4, 5, no, 6, 7. Now, the thing is, if I look 2 divisible by 2, it might be divisible by 4, might not be. I cannot conclusively say. 3 might be, might not be conclusively. I can't say anything. 6 might be divisible by 4, might not be. Conclusively, I cannot say. 7, conclusively, I cannot say. That means I am not able to say precisely anything in this regard. So, maybe I will be able to find it. Right? Now, mind it, m should be divisible by 1, 2, 3, 6, 7. That means it should be a multiple of 2, it should be a multiple of 3, it should be a multiple of 6, it should be a multiple of 7. Now, there are too many numbers. Right? Common multiples I need to take. Common multiples. Let me find out the least common multiples, right? If I can find out the least common multiples, any multiple of that would be here. So let me check for the LCM. Now, LCM in this case will turn out to be 42. Right? Let me check. 42 is definitely not divisible by 4, not divisible by 5. Done. 42 is divisible by 1, 2, 3, 6, 7. That means I am able to find m. That means I am able to find x. if there is an x for which the two conditions are satisfied, that means this n is a Nella number. Right? That means what he has said, for example, n is equal to 7 is a Nella number. For that, we have been able to find such a x equal to 4, for which there is an m which satisfies the two conditions. Right? This is what we have understood using the example. But that is not a question. Our question is there. Let me just erase it and then I'll move on to the question. Right. My question is, how many Nella numbers are there which from 50 to 61? Or I can just write it like this. 50, 51, 52, so on, till 61. Both include. So I need to see how many Nella numbers are there amongst these numbers. Right? Question paper is there in the description box. I'm not writing it because I need this. I need to check whether this is a Nella number, whether this is the one, this is the one, this is the one, and so on. So let me start with the least one. Let me take n as 50. I need to check whether n is equal to 50 is a Nella number or not. For that, I need to have an existence of x. Right? I need to have an existence of x. Now, x should be what? Less than n. That means possible values of x 1, 2, 3, so on till 40. Cool. Now, along with this, I should be able to find positive m such that m is not divisible by x plus 1, and m should be divisible by every other positive integer from 1 to n. Right? Now the thing is, I have too many options for x. Let me start with first one, x equal to 1. Mind it, x equal to 1. It's a very obvious thing. Let me see whether I can find m or not. Now I want m which is not divisible by 2, which is not divisible by 1 and not divisible by 2. But it should be divisible by 3, 4, 5, 6, so on till 50. Right? Now any number which is divisible by 3 would be divisible by 1, right? So obviously x equal to 1 to nahi hota. Now what about x equal to 2? Again the same thing, right? Because I need a m which is not divisible by 2 and not divisible by 3. Right? So I need m which is divisible by 1, 4, 5, 6, so on till 50. Now any number which is divisible by 4 must be divisible by 2. Right? That means if I want to look for such number, I will look for the tiny number. Why? Because prime factors, if I take 3, obviously I will have 6. Right? Every other 6 would be there and 3 is there. Then if I take 11, even if I take 11, every other should be divisible by 22. Again factor of 11 is there. That means if I want to look for x, I will look towards the bigger side, right? To the other end. To the other end. How should I start? To the other end. Now, obviously, I would want to look for a prime number, right? To the other end. Let me see. 50, less than 50, which prime number can I take? 47. Let's see what happens. So let me take x equal to 47. Let me check. Right? I need to find m which is not divisible by 47 and not divisible by 40. But it should be divisible by every other. So it should be divisible by 1, 2, 3, so until 46, 49, and 50. Right? This is absolutely fine. 47 is a prime number. I get it. 48. Now 48 is nothing but 2 raised to 4 into 3, right? 16 into 3. Now obviously m would be divisible by 16 and m would be divisible by 3. That means m would be divisible by 40. So that means contradiction is there. I cannot have x equal to 47. Let me go further down. So x equal to 47. Instead of that, I can go x equal to 47. Right? That means I want m such that it is not divisible by 43 and not divisible by 40. Right? Okay. And m should be divisible by every other. So 1, 2, 3. I will have 42, I will have 45, and so on till 50. Right? Mind it, any number, because 44 is there, that means 4 into 11, m is divisible by 4 and m is divisible by 11. Both are there, right? So if it is divisible by 4, it is divisible by 11. It has to be divisible by 44. Contradiction is there. That means x cannot be 44. Rejected? Okay. X equal to 41. Now, not divisible by 41, not divisible by 42. Find it. 42 is 7 and 6, right? Obviously, the number would be divisible by 7 because every other he says, and it will be divisible by 6. Rejected, right? You can check for x equal to 37 yourself. I will go to x equal to 31. Let's see what happens. Right? Now x equal to 31. M. It should not be divisible by 31 and it should not be divisible by 32. Right? M should be divisible by every other. 1, 2, 3, so until 30, then I will go 33, then I will go 50. Right? Okay. Now there is a problem. Now I am unable to think. So what I'll do is M is divisible by all of these. So let me write the LCM. Now LCM I can write in terms of prime factors, right? So 2 part would be there, 3 part would be there, 5 part would be there, and so on. Let me write the LCM. Now highest, when we write LCM, we write the highest power of 2. Now mind it, 16 would occur, then 32 is not there, then there. Right, so 16 have the maximum power of 2. That means in LCM, I will have the maximum power as 2. Right, so in my LCM, I have 2 raised to power 4. Right, 2. And then I have 3 raised to power, the highest power would be 3 because 27. Right, and so on. Now, the thing is, M is divisible by this number. Right, or maybe I can just take M to give you the LCM. Right. Any number which is divisible by 2 raised to 4 as in 16 might not be divisible by 32. Right? Yes, that means I found this. And 31 to I needs to, so I must. That means if I take my M to be LCM of these numbers, right, I will get such an X. Now, if I'm able to find the existence of X, that means my number N is equal to 50 is a Nella number. Right? So that means this is the Nella number. Let me check for N is equal to 51. So check that. Okay, 51. 51. Let me write this thing. Mind it, let me check there itself. Let's see what happens. Right? M should be divisible 1, 2, 3. Let me go on to 51. Right? Absolutely fine. Because 51 is nothing but 17 into 3. Again, 17 I over. 3 is already I over. Again, my LCM will look something like this. Right? Again, this number is not divisible by 31. This number is not divisible by 32. Again, I have an existence of a number x, so that we have n is equal to 51 as a number. Right? Let me check for 52. On the same lines I can do. If I do 52 also, no problem. That means 52 is also there. Right? And so until, let me talk about 61. Right? Now, 61. So again in my LCM, right, maybe I will get my 61. This number is definitely not divisible by 31 and this number is definitely not divisible by 32. So there is an existence of an x, which is x equal to 31, which will make n is equal to 61 as my Nella number. That means all of these numbers are Nella numbers. He asked me how many Nella numbers are there from 50 to 61, both inclusive. All of these. How many numbers are these? These are 12 n numbers. So that means the answer for the first part is 12. Right? Now, I will continue with the analysis that I have done for the second part. Now, the thing is, for the second part, the question is, you need to find the number of Nella numbers from 50 to 2070, both inclusive. Right? Now let's see what happens. Now I was continuing with this number itself. Let me put 62 also. Let me put 62. Let me check because I've already checked to 50 to 61. Let me go for 62. Let's see what happens. Now 62 I will put my 62. Mind it, now in the LCM I will have 62. Right? Okay, in my LCM I have 62. If I write the prime factorization, that is 2 into 31. That means this number now becomes divisible by 31. So x equal to 31 cannot be the existent x for this one. Right? Okay, fine, cool. So 31 nahi mila mujhe, jo mujhe mil raha tha baar baar. Right? So the question is, I have been stuck because wo mujhe mil nahi raha. So let me check for n is equal to 60. Right? And x equal to 31 does not work for me. I will not go for the prime numbers less than this because I can clearly see that will not be the case. So I will go on the higher side. Higher side, higher side, higher side. Ab 41, 50 to 61 के लिए नहीं मिल रहा था. Obviously 62 के लिए तो नहीं मिलेगा, right? 43 no. Then 47 no, because it was not even there for 50 to 61. How can it be there for 52? So let me move back up. Right? X equal to 47. Prime number greater than 47. That is 53. So let me take my x to be 53. X less than 62 I want, and I will take my x to be 53. Right? I will erase this now. Alright, I'm erasing the answer for the previous one also because now I need more space. Cool. Now, x equal to 53. That means I want m which will not be divisible by 53 and not by 54 because x plus 1. Right? Okay. Now, what else? Also, I want m to be divisible by 1, 2, 3, so until I will get 52, I will get 55, I will get 52. Right? Now mind it, when I write the LCM, this is nothing but 2 into 27, 2 is present over here and 27 is present over there. That means this m will not work. Right? This m will not work, that means this x will not work. This x is not working. So 53, if I go beyond 53, 55 no, 57 no, 59. I can check for 59. Now if I want to check for 59, so this is not divisible by 59, not divisible by 59. Again, when I'm writing the LCM, right, I can rectify this. I will go to 58 and then I'll go to 61 and then 62. 62. Right? Now, 60 is nothing but 15 into 4, so 3 into 5 into 2 square. Obviously, 3 is there, 5 is there, 2 square is there. That means the LCM would be divisible by this. So, 59 doesn't work. Right? Next prime number that I can use, that is 61. Now, 61, this is 60. Again, this is 2 into 31. Already it's there. Cool. That means I am unable to find x. That means n is equal to 62 is not my Nena number. First number I have, this is not my Nena number. Right? Let me check for 63 now. Let's see what happens. So, 63. Right. Right. I have checked for x equal to 61. Obviously, since it didn't even work for 62, how can it work for 63? Okay, rejected. 63 was also done. 64, you will realize it is not done again. Then I have my 65. Let's see whether that works or not. Now, let me put it here. 65 and x less than 65. Right, 63 is not my prime number. Right? You'll realize if it is not even working for 62, 63, 64, it is not going to work for 67, then 66, and so on. The thing is, I'm unable to get the thing. But why is that happening? And if I want to find Nena numbers, where should I go in order to find it? Where should I go? Now, the thing is, when we were analyzing, the first thing that we got, x turned out to be 31. Right? We took m not divisible by 31 and not divisible by 31. Now 31 was a prime number, perfect. And 32 is actually a nice number, isn't it? It is 2 raised to 5. Not a coincidence, 2 raised to 5. That helps me out. Now, let me see. 62, 63, 64, 65, 66. Let me move forward, but till there. Right, 64 2 raised to 6 होगा, right? इसके आसपास ही थी मैं. अब मैं जाती हूँ next बार के पास. So let me take 127. Let me see what happens. Right, so I will take my n as 127. Right, that means I need to find an existence of x which is less than 127. That means x can be 1, 2, so on till 126. And I need to find m which is not divisible by x and by x plus 1 but is divisible by every other. So let me look for my x. Obviously x I'll take it to be a prime number. Let's see what happens. So first prime number that I can think of, that is 119, which is not 113 is the one. 113 is the prime number. Yeah, 113. Right? Now, if I go to this one, I need to find m, which is not divisible by 113 and not divisible by 114. But it should be divisible by every other. So 1, 2, 3, so on till 112, 115, 126, 127 actually. Right? Okay. Now the thing is, here number 114, you can write it as 2 into 57. 57 will crop up and 2 will be there, so it's fine. So that means x equal to 113 will not work. Right? X equal to 113 is not working. That means I will not go further in. I've checked the largest prime, it is not even working. So lesser one, it will not work. So that means n is equal to 127 is not a number. Similarly, you can check for 128. Right? Let me check. In fact, you can do that for yourself. Right? It will also not turn out to be a number. Let me go for 129. Let's see what happens. 129. So I want x less than 129. So that means I'll go till 128. Right? Now, I will go for the prime numbers. Prime numbers less than 129. So that is 127. Let me see whether I get an Ella number or not. Right? So I want m, which is not divisible by 127 and not divisible by 128. Now 128 I like it. It's a power of 2. 2 raised to 7. Right? And it should be divisible by every other. 1, 2, 3, so on till I have 126, I have 129, and then I have 129. Cool. Right? Now the thing is, if I write the LCM of this one, the highest power of 2, that is 64. So that is 2 raised to 6. Right? That would be there. And obviously 3 raised to, it would be 81, right? Yeah, 81. 3 raised to 4 into something. This number is definitely not divisible by 127. And this number is not divisible by 128. Why? 2 raised to 7, 2 raised to 6. Right? Okay. That means I got x equal to 127, which is making my 129 a number. Right? Let me check for 130. Same thing will work for 130 also. 131, 132. That means in this chunk again I am getting my number. Now, obviously I am getting all of these numbers. Now, where should I check next? Mind it, near the power of 2, 64, 128. So I can check for 254. Check it out. Right? It will turn out to be not a Nana number. 255, not a Nana number. 256, not a Nana number. Right? That means in these chunks you will check. And then you will check around 512. Then you will check around 1024. Next part we have it 217, that is 2048. That's it. Right? So if you want to look for numbers, look in these chunks. Around 64, like 50 to 63 you can check. Then 65 to 128 you can check. 129 to 254 you can check. So check in these chunks. Right? Now, answer turn out to be from 50 to 60 because this is very aage hamare paas 12. Right? And in the next one, you will find 124, and then in the next one you get 255, or you interchange it, whatever you want to call it, right? So these are all the Nana numbers. So in total, I have 393 Nana numbers, right? In the question, he does say write the sum of digits of k. So obviously, the answer in this case for the second part, that is 50. Right? Now, mind it, 10 marker is an investigative question, right? You need to find an answer. You don't need to prove whether there's an existence or not. So, through hit and trial, if you are able to find the numbers, because step by step, I have exhausted all the numbers from 50 to 2017. Obviously, I did not take one by one. I did not do that. But I did exhaust from 50 to 2017. So hit and try is a great method in 10 marker. If you are unable to devise the method, just exhaust all the cases. It does not take that much time. Right? After all, it is a 10 marker question anyway. Right? A 10-digit number is said to be interesting if its digits are all distinct and it is a multiple of 11,111. Let k be the number of interesting integers. Write the sum of the digits of number k. Basically, I need to find the number of interesting digits. Now, interesting digits is a 10-digit number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And its digits are all distinct. So A, B, C, D, E, F, G, H, I, J. So that I can see that all the digits are distinct. But I know that A will lie between 1 and 9, B will lie between 0 and 9, C will lie between 0 and 9, and so on. And it is a multiple of 11,111. This number is divisible by this. Okay. Now, what else do I know? Divisibility. Let's talk about divisibility. This number is divisible by this. Do you think this number will be divisible by some other number? Now, he says all the digits are distinct, right? Now, how many digits are there? 10 digits are there. That means 0 to 9, all the digits will be involved in the number. Right? 0 to 9, all the digits are involved. Now, if I add 0 plus 1 plus 2 plus 3 plus so on till 9, as in sum of first 9 natural numbers, that turns out to be 45. If I add all the digits, the sum turns out to be 45. Sum is divisible by 9 because 45 is divisible by 9. If sum of the digits is divisible by 9, the number is divisible by 9. So I just established, since we were talking about divisibility, I just established that this number is divisible by this as well as this. Now obviously these two are co-prime numbers. That means the numbers would be divisible by 99,999. Right? Now this is a very nice number. Why is this a nice number? Because 999 comes. So basically this is nothing but 10 raised to the power 5 minus 1. Right? But the question is, what is the benefit of this? I need to find the number of interesting digits. So basically the corresponding values of A, B, C, so on till J. Right? Okay. Now I only know that this number is divisible by this or this. Now since divisibility, I am talking about divisibility, somehow I need to generate 10 raised to the 5. Now I can write the number in the expanded form, but I need the expanded form to definitely include 10 raised to the 5. Right? So I will write expanded form in a different kind of manner. What I'll do is, I will take this number. Right? I will write the expanded form A, B, C, D, E into 10 raised to the 5. Right? 1, 2, 3, 4, 5 plus F, G, H, I, J, whatever this number is. I've specifically written the expanded form in this way. Why? Because I wanted to involve 10 raised to the 5 because I can see. Right? Okay. Now, this number, this is the same number basically, this number is divisible by 10 raised to the 5 minus 1. Right? If we divide this, let's see what happens. Let me divide this by this. We know how division works, right? So this is the divisor 10 raised to the 5 minus 1. And that is my number A, B, C, D, E into 10 raised to the 5 plus F, G, H, I, J. Right? So obviously, since this is there, I'll do 10 raised to the 5 into A, B, C, D, E. So this into this is the first quantity, A, B, C, D, E into 10 raised to the 5 minus A, B, C, D. Right? Subtract this, minus, plus. This gets cancelled. So basically, I'll get A, B, C, D, E plus F, G, H, I, J. Now, since I know that this number, this number is exactly divisible by this. So this remainder that I'll get, right? What can be the possible forms of the remainder? Now, remainder, obviously this is not 0. So that means whatever this comes, this has to be divisible by this. So that means this number, A, B, C, D, E plus F, G, H, I, J is divisible by what? Which number? 10 raised to the 5 minus 1, which is 99,999. This number is divisible by this. Right? तो divisible है, ये number हो क्या कह सकता है, right? Either this number can be this or some multiple of this, or maybe I can say 2 into 99,999. Okay. And or possibilities नहीं बनेंगे because adding two 5-digit numbers will not give me 3 into 99 raised power 99,999, right? Or multiples नहीं बनेंगे. So now that I think about it, even this multiple is also not possible. Why? Because if you can see A, B, C, D, E, all the distinct numbers are there. Definitely this number is less than 99,999. Also, all the distinct digits are distinct. So F, G, H, I, J, definitely less than 99,999. If I add these two, right, add them up. Don't you think it will be less than 2 raised to 99,999? Right? So this term is less than this. So equal कैसे होगा? The only possible case is if I add these two, that can be equal to or that must be equal to 99,999. Alright. Okay. Now this is a very interesting condition that we have arrived on. Right? So I am going to erase this because I need this space. Now we have approached that, we have arrived at that A, B, C, D, E plus F, G, H, I, J. In fact, let me write it like this so that I can better see it. F, G, H, I, J. If I add the two, I will get 99999. Right? Now mind it, I have to have E plus J and the unit digit has to be 9. Now this is a digit, this is a digit. Maximum can be 9 and maximum here can be 8. Right? 9 plus 8, that means 7. उससे पहले 6, then 5, then 4, then 3, 2, 1, 0, then 9. 9 can only be possible if E plus J is equal to 9. Right? Similarly, here 9 will only be possible if D plus I is equal to 9 and C plus H is equal to 9 and D plus G is equal to 9 and A plus F is equal to 9. Right? If this has to be satisfied, this has to be satisfied. Now mind it, I need to write 9 as sum of two numbers, right? And how many different ways can I do that? I know that digits are 0 to 9. So let's see. 0 or 9, 1 or 8, then 2 and 7, 3, 6, 4, 5. And then repetition is there. Let me write it down. 5, 4, 6, 3, 7, 2, 8, 1, and 9, 0. Right? So if I'm talking about E and J, right? Either EJ will be 0, 9 or 1, 8, 2, 7, 3, 6, 4, 5 or 5, 4. You can see the 10 possibilities. Right? So let me see. E, J. Right? Any of the 10 possibilities it can be. Right? So 10 different ways. Corresponding to this, now let's talk about D and I. Right? Suppose for E and J I took 1, 8. Right? Now, D and I, do you think it will have 1, 2, 3, 9 possibilities? Careful. If I have rejected 1, 8, I cannot take 8, 1. Digits are distinct. 1 and 8 have been used. That means I cannot use this. So, D and I will have 8 possibilities. Right? Now, let's talk about C and H. C and H. Suppose for D and I took 3 and 6. So, 6 and 3 already rejected. So, C and H will have 6 possibilities. Right? B and G will have 4 possibilities and A and F will have 2 possibilities. Right? So, you can find that out. But we did one thing wrong. What was it? I need a 10-digit number. 10-digit number, that means, do you think A can be 0? No. A cannot be 0. But you have counted here when A is equal to 0. That's it. So subtract the cases. You have counted extra cases. Just to subtract the extra cases. Let's see. What are the extra cases? When A is 0, right? Now if A is 0, F has to be 0. So that means you have taken the case of 0 and 9. And then BG as it is. Then CH as it is. then Di as it is, and Ej as it is. Right? Now let's see how many cases would be there. Now this is fixed. Now BG. Now 0 and 9 have been fixed. Okay, so ignore, just focus on this marker now, ignore the red one, right? So 0 and 9 have been rejected, 9 and 0 have been rejected. So BG either can be 1, 8, 2, 7, 3, 6, 4, 5, or 5, 4, 6, 3, 7, 2, 8, 1. So that means it has 8 possibilities. Right? So if I take BG to be 2, 7, along with this I will reject 7, 2 also. Distinct digits are there, don't forget it. C and H will have 6 possibilities. Then corresponding B and I will have 4 possibilities. E and J will have 2 possibilities. So these are the number of cases when 0 is at the first place and I don't want these. So subtract this minus this one. 8 into 6 into 4 into 2. Right? You subtract it and you'll get the number, which is a very nice number. I'll write it here. 3, 4, 5, 6. Right? This is the number of interesting digits. Now, the number of interesting digits is also interesting because 3, 4, 5, 6. Right? So, then K is this. Write the sum of the digits of number K, and that turns out to be 18, which is the final answer. Alright, on to the next one. Now, he says if n is the number of ordered pairs of positive integers a, b, such that the LCM of the two numbers is this, then write the value of n by 45. So basically, I need to find the number of ordered pairs a, b such that the LCM is this, right? So LCM is given to be 2q into 5 raised by 7 into 11 raised by 30. Right? I need to find the ordered pairs a, b. Mind it, LCM is given to us, lowest common multiple. Right? Okay. Now we need to talk about a, b, the possible values of a and b. Mind it, a can have a factor of 2, right? And maybe some power of it. Okay. Along with this, it can have a factor of 5, may or may not have, right? 5 and its powers, and 11 and its powers. Right? Other than these 3 prime factors, there is no other possibility for another prime factor. Right? Because it would have otherwise cropped up in LCM. So that means the only prime factors in A that can be there is 2, 5 and 11. Maybe all are there, maybe 1 is there, maybe 2 is there. Right? Okay. Now, B, obviously it might have a power of 2, it might have a power of 5, it might have a power of 11. Other than these 3 prime factors, there is no other possibility. So if I need to find out the number of ordered pairs, I need to find the different powers of 2, the different powers of 5, the different powers of 11. Right? Now he says that LCM is 2 raised by 3 into 5 raised by 7 into 11 raised by 13. Right? Now let's go back to junior classes. How do I get this 2 raised by 3 in the LCM? Mind it, I am talking about the lowest common multiple. Right? So suppose I have a number where the power of 2 is 2 and the other power is 2 raised by 3. So in the LCM, I would have 2 raised by 3. I am not talking about the other prime factors which are there. I am just talking about a single prime factor and its power. Right? Another case, let us take power 3. Suppose one power is 4, the other power is 7. In the LCM, I would have 3 raised by 7. Right? The higher of the powers goes. Now he says in LCM I have 2q, 2 raised by 3. That means the higher power has to be 3. Either it can be here or it can be here. Interesting. So let me talk about powers of 2 only. Powers of 2. Right? So A and B. Powers of 2. Right? So maybe A has the highest power, which is 3. Corresponding to this, there might be a case where B does not have any power of 2, but it can be there. Because if I have 2 raised by 3 and 2 raised by 0, obviously in LCM I will take 2 raised by 3. Cool? Right. Now again, let the power of 2 be 3, but corresponding to this, let the power be 1. LCM would have 2 raised by 3. Another case. Then 3, 2. LCM would have 2 raised by 3. Then 3, 3. Right? In this case, the highest, obviously they are the same, the highest would be 3. Done? Now, you think I can have 3, 4. Mind it, if I do that, my LCM would have 2 raised to 4, but my LCM has 2 raised to 3. That means this power cannot exceed 3, right? So maximum 3 can be there. Mind it, I am interested in the ordered pairs, right? So that means I can have 3 over here and 0 over here, right? I can have 3 over here, 1 over here, 3 over here, 2 over here, 3 over here, 3 over here. This I have already written. Don't write it again. Careful, right? So these are the corresponding powers of 2 which are possible, right? As you can see, corresponding. I've written it. Yeah. 2 raised to 3, 2 raised to 2, 2 raised to 3, 2 raised to 3, then 2 raised to 0, 2 raised to 3, then 2 raised to 1, 2 raised to 3, 2 raised to 2, 2 raised to 3. Right? That means these are the corresponding powers of the 2. Now, either this will happen, this is one case only, or this will happen, or this will happen, or this will happen, or this, or this, or this. That means among these 7, there has to be one possibility. Right? So, first I need to talk about powers of 2. Powers of 2. How many possibilities do I have? I have 7 possibilities. Right? Other than these, I cannot have any possibility. Interesting. Now, let's talk about power of 5 then. Right? So, I will erase this now. Let me talk about power of 5. Now he says my LCM has 5 raised to 7. That means the highest of the powers is 7, right? Maybe A has 7. Corresponding to this, maybe the power here is 0. So that means 5 raised to 7, 5 raised to 0. Another case, 7 and 1. As in 5 raised to 7, 5 raised to 1. Right? Next 7, 2, 7, 3, 7, 4, 7, 5, 7, 6, 7, 7. Now obviously I cannot go 7, 8. I need to reverse it now. 7, 0, 7, 1, 7, 2, 7, 3, 7, 4, 7, 5 and 7, 6. Right? Either this case will happen or this or this or this. And how many cases these are? These are 15 in number. Right? So that means powers of 5. They can be arranged in 15 ways. Last is powers of 11, that you will find out for your own good, right? That is powers of 11. Right? This will actually turn out to be 27. Right? Here I have talked about the powers individually. I need to make a number. Right? Now, powers of 2 can be arranged in 7. Now, I need to arrange powers of 5 also corresponding to this. Right? I need to arrange powers of 11 also corresponding to this. I think answer is there. Number of ordered pairs 7 into 15 into 27. Right? That is equal to n. But I do not want n. I want divide by multiply. Right? You can divide it, and that is why the answer for this question turns out to be 63. Right? So I will read the question. Now he says all integer multiples of 9 are written as a sequence. I have written some of the terms of the sequence and the sequence is moving along. Right? And for each of these numbers, sum of its digit is written. Right? For each of these numbers. So sum of digits here is 9, 9, 9 and so on. It is written. Now he says in the latter sequence, which sequence? The latter one, where the sum of the digits I have written. Right? In the latter sequence, 36 repeats in 3 successive terms for the first time. Right? Suppose 9 into k, 9 into k plus 1, 9 into k plus 2 is the instance when it happens. Then you need to write sum of squares of digits of k. Basically, you need to find the value of k. Basically, you need to find which multiple of 9 is there. Right? Okay. So let's start. Now, first of all, I will need to write the latter sequence, which is the sum of digits. Here, sum of digits is 9, 9, 9, 9, 9, 9, 9, 9, 9, 9. Okay, cool. 18, right? 9, 9, 9, 9, 9, 9, 9, 9, and 9 again. Okay, now 18, 18. Okay, then 9, 9, 9, 9, 9, 9, again 9, 9, then I have 18, 18, 18. Okay, right, and then 9, 9, 9, 9, 9, 9, 9. And let's move forward, right? Next one मुझे दिखता है 369 होगा, right? Then 378, then 387, then 396. So obviously the digits 18, 18, 18, 18, and then the 9 patterns continue. Right? Okay. Now he says that in the latter sequence 36 digits. Now before we go on to benefits, let's just try to observe what is happening. 18, 18, 18, 18. First of all, 18 is lonely. Then 18 occurs twice. Then 18 occurs thrice. Then 4 times. And next, मुझे एक और लिखना चाहिए था. That would have been. अच्छा, वो तो आगे जब तुम लिखोगे you'll get it, right? So as you can see, 18, 18, 18, 18. This pattern is going on. So if I need to guess, when does 18, sum of digits 18, occurs next? If I have to guess, what will I do that? Now observe it. Here 99 is there, 189, 198, then 279, 289, 297, 369, 378, 387, 396. Observe these numbers. कुछ repeat तो नहीं हो रहा? Okay, let's see. यहाँ पे 9, then 89 पे गया, then 79 पे गया, then 69 पे गया. Next कैसे जाएगा? 59. Obviously 1, 2, 3, 4. Check करें sum of digits 18. अब check करते हैं whether consecutively, और मुझे पास लिखना चाहिए, consecutively 5 times आ रही है. So 459 के बाद 468, then 477, 486, and 495. Yes, consecutively you are getting 5 times 18. Right? Next you have to guess 69, 59, then 49, then 39, and so on. So I'm hoping that you are able to recognize the pattern. Right? Now, if I say, because यहाँ पे तो open sum of digits 18 है, मुझे sum of digits increase करना है, because अब मुझे 36 चाहिए, right? तो मैं 27 लेके आती हूँ. 27 लाऊंगी कहाँ पे? Right? अब first time देखें, अब यहाँ पे 9 से छोड़ो, यहाँ पे 89 से start करो. Last 2 digits में 89 डालते हैं. Right? और मुझे sum of digits चाहिए 27 पे जा रहा है, right? Because I'm increasing myself from 18 to the number, right? Okay, so यहाँ पे 89 है, यहाँ पे क्या डालूं? Now this is 17, right? So मुझे 27 चाहिए, तो यहाँ पे 10 होना चाहिए. So maybe I can put 1, 9, right? अब 17 और किससे आ नहीं सकता था, so that means this is also one such number. This is a 4-digit number where the sum is equal to 27. ठीक है? अब next वाला try करें. Next वाला कौन सा होगा? Obviously 1989 है, so 1998 होगा. ये भी 27. Because मैंने second वाले से pick up किया था, so that's why consecutive 2 बार आ रहा है, right? अब मुझे अगर next वाला pick up करना है 79 से, यहाँ पे 79 डालते हैं. Right? Now the sum is 16 here, right? 16. अब यहाँ पे मुझे चाहिए 11 sum. So 11 के लिए मैं 29 कर सकती हूँ. 29 कर सकती हूँ. 29. Right? Next 2988, 2997. 3 times आ गया. Then 4 times में you know what to do. 6 9 पे आ जाएगा. साथ में तुम्हारे पास 3 9 आ जाएगा and move on. Right? But my aim is not to find the digits, sum of digits to be 18 or 27. My aim is to find the sum of digits to be 36. Now, number 36 है. Now, sum of digits 36 है. 36 maximum, सबसे minimum times कब आ सकता है? अगर मेरे पास 999 हो, फिर तो एक ही बार आएगा, right? Because जैसे मैं next पे जाऊंगी वो चला जाएगा. 36 will not be there. Right? So that means जो मुझे numbers ढूंढने हैं, वो 4 digits से ज़्यादा, that means 5 digit numbers होने चाहिए. 1, 2, 3, 4, 5. Right? And for the first time भी ढूंढने हैं मुझे, right? और अब first time ढूंढने हैं and 3 successive terms में आना चाहिए. 3 successive कहाँ पे है? 3 यहाँ पे. That means 79 बाद में आना है. 79 होगा, then 88 होगा, then 97 होगा. Right? अब मुझे smallest number में चाहिए था, right? Because for the first time आ रहा है. तो अगर suppose मैं यहाँ पे डाल देती हूँ 1, तो smallest चाहिए तो आगे सबसे छोटा डालेंगे. अब यहाँ पे 16 हो चुका है. यहाँ पे 17, मुझे आगे कितना जाना है? 17, okay, 36, 9, 17, that is 29. Wow, 19. 19, राइट। अब यहाँ पे सम ऑफ डिजिट्स 19 तो हो नहीं सकता, सम ऑफ डिजिट्स मैक्सिमम 18 होता है, राइट। सो दैट मींस यहाँ पे 1 नहीं होगा, यहाँ पे 2 होगा। जहाँ पे 18 चाहिए, अब 18 में कर सकती हूँ 9, right? This is one such number. Next number would be 2998. 2997. Just by observing the pattern over here, you were able to get the pattern. Then it was 20, sum as 27. Then the sum is 36. So always when you have to observe, start from the smaller number so that you can easily look at the pattern and observe it. Right? So that means this is the first time these sum of digits occur thrice or in consecutive terms. So this is my 9k. This is my 9 into k plus 1. This is my 9 into k plus 2. Okay, so easy निकाल लेते हैं. Divide this number by 9. So this is 3, 3, 3 and 1. So k turns out to be 6. But I want what? Sum of squares of digits of k. So 9 into 3, 48 plus 1. The answer is 49.
2 raised power r be the remainder when 3 raised to the power 2 raised to the power 2022 minus 1 is divisible by 2 raised to the power 2025, मतलब ये next year. ठीक है? Write the sum of squares of digits of r. ठीक है? मतलब कि r निकालना पड़ेगा, फिर जो भी उसके डिजिट्स होंगे उनका स्क्वायर करके सम करना है. तो मतलब कि r निकालोगे तभी कुछ होगा. ठीक है? रिमाइंडर दिया हुआ है, आपके पास डिविडेंड दिया हुआ है, डिवाइजर दिया हुआ है. मेरे ख्याल से सबको पता था. आई एम गोइंग टू यूज डिवीजन एल्गोरिथम. ट्राई करना पड़ेगा. 3 raised to the power 2 raised to the power 2022 minus 1, ठीक है, is divided by 2 raised to the power 2025 into some quotient plus remainder 2 raised to the power. कोई रिमाइंडर होगा. ठीक है. अब सिंपल सी चीज है, मेरे को निकालना है ये. दिस इज टू बी फाउंड. ये निकलेगा कब? जब मैं इसको देखूंगा. ठीक है. 3 raised to the power 2 raised to the power 2022 minus 1 डिवाइड करूंगा इससे 2 raised to the power 2025 से. मतलब कि डिवाइड करा 2025 से, तो अगर मैं ये चेक कर लूं कि इसमें कितनी 2 की पावर्स आ रही हैं, 2 की पावर्स काउंट कर लूं, तो मैं डिवाइड कर सकता हूं और जो बच जाएगा वो रिमाइंडर होगा. तो मतलब कि मेरे को 2 की पावर्स के लिए मतलब कि हाउ मेनी टूज आर प्रेजेंट. ठीक है भाई, कितने टूज आ रहे हैं इस नंबर के अंदर, मैं जब डिवाइड करूंगा तो मेरे को रिमाइंडर मिल जाना चाहिए. ठीक है. कितने टूज आ रहे हैं ये गिनना पड़ेगा मेरे को. तो अब टूज गिनने हैं. ठीक है. 2 इतना तो समझ आया, टूज गिनने. अब इसका करें क्या? 3 की पावर 2 की पावर 2022 माइनस 1. यार इसको ए स्क्वायर माइनस बी स्क्वायर यूज करके फैक्टराइज नहीं कर सकते? फैक्टराइज तो हो सकता है मेरे ख्याल से. चलो एक काम करते हैं, फैक्टराइज करने की कोशिश करते हैं. 3 raised to the power 2 raised to the power 2022 minus 1 स्क्वायर करना पड़ेगा. तो एक काम करते हैं, एक 2 अलग कर लेते हैं इसमें से. 2 raised to the power 2021 into 2 एक अलग कर लिया. ठीक है. इसको लिखा 3 raised to the power 2 raised to the power 2021 का स्क्वायर माइनस 1, राइट. और इसको लिख लिया 3 raised to the power 2 raised to the power 2021 minus 1 into 3 raised to the power 2 raised to the power 2021 plus 2 raised to the power तो गया ही नहीं, 2 raised to the power 2021 plus 1. ये बना. इससे तो 2 की उस पर पहुंच ही नहीं रहा भाई. ये फिर से फैक्टराइज हो सकता है फर्दर. ठीक है. इसको फर्दर फैक्टराइज करते हैं. 3 raised to the power 2 raised to the power 2021 इसको तोड़ लेते हैं. 3 raised to the power 2 raised to the power 2020 into 2. ठीक है. तो मैं इसको फिर से लिख लूंगा 3 raised to the power 2 raised to the power 2020 का स्क्वायर माइनस 1. इसी को यूज करो 3 raised to the power 2 raised to the power 20 minus 1, 3 raised to the power 2 raised to the power 20 plus 1 into 3 raised to the power 2 raised to the power 2021 plus 1। ये था मेरे पास अभी तक, ठीक है यार। ये तो फिर से फर्दर फैक्टराइज हो जाएगा, मैं इसको फर्दर फैक्टराइज कर देता हूं। तो पता है कैसे लिखना है, 3 raised to the power 2 raised to the power 2019 minus 1 and 2019 plus 1 and 3 raised to the power 2 raised to the power 2021 plus 1। ये तो फिर फर्दर हो सकता है, मतलब कि पैटर्न बन गया। हम पैटर्न बना सकते हैं और 0 तक ले जा सकता हूं मैं इसको, ठीक है। तो आप पैटर्न से लिखो क्या बनता है, 3 raised to the power 2 raised to the power 2021 plus 1, 3 raised to the power 2 raised to the power 2020 plus 1, 3 raised to the power 2 raised to the power 2019 plus 1, और इसको फर्दर तोड़ा, ठीक है। ऐसे ऐसे चलते जाओ, ये प्रोडक्ट में आ रहा है। लास्ट नंबर तो मेरे को पता है क्या होगा, 3 raised to the power 2 raised to the power 0 minus 1 फिर प्लस 1। तो प्लस 1 को पहले लिख लेता हूं फिर माइनस 1, ठीक है, वो इकट्ठा आ जाएगा, यहां आ गया। और इससे पहले वाले में क्या होगा, 3 raised to the power 2 raised to the power 1 plus 1, तभी तो फर्दर माइनस वाले को तोड़ा था वो। इससे पहले वाला क्या होगा, 3 raised to the power 2 raised to the power 2, ठीक है। ये पैटर्न बन गया, मैंने ऐसे लिख लिया, ठीक है। अब इसके अंदर 2 की पावर ढूंढते हैं। 2 की पावर 0 1 हो गया, 3 minus 1 ये तो 2 हो गया, 2 की पावर 1, ठीक है। 2 की पावर 0 1 हो गया, हाँ 2 की पावर 0 1 हो गया, तो 3 plus 1 4 हो गया, 2 का स्क्वायर लिख दिया, ठीक है। अब ये तो 2 ही है, तो 3 का स्क्वायर 9 plus 1 10, इसमें एक ही 2 है, ठीक है। अब 2 की पावर 2 की पावर 2 4 हो गया, 3 raised to the power 4 81 हो गया, प्लस 1 82, यहां पे भी एक ही है। अब सेम वे अगर आप इसमें भी देखोगे, इसके अंदर भी एक 2 आ जाएगा, एक 2 आ जाएगा, एक 2 आ जाएगा। कैसे सोचा यार, ये तो ऑड नंबर है, प्लस 1 इवन इवन इवन, सबके अंदर कम से कम एक 2 तो होगा ही होगा, बिकॉज ऑल आर इवन नंबर्स। अब झगड़ा यहां नहीं है, झगड़ा यहां है कि 2 की पावर 2 भी हो सकती है इसमें, कहीं पे 2 की पावर 3 भी हो सकती है, कहीं पे 2 की पावर 4 भी हो सकती है। इसमें ये भी तो फैक्टर्स हो सकते हैं, मैंने तो सिर्फ एक इवन नंबर से ये बता दिया, 4 इज एन इवन नंबर, 16 इज एन इवन नंबर, और उसके अंदर 2 की पावर 2 भी होती है और 2 की पावर 4 भी होती है रिस्पेक्टिवली। तो मतलब कि मैं एक काम करता हूं, डिविजिबिलिटी बाय 4 चेक कर लेता हूं। डिविजिबिलिटी बाय 4 अगर मेरे को किसी में मिली तो मैं वहां पे 4 की पावर्स लिखूंगा, मतलब कि 2 की पावर 2 लिखूंगा, और फिर 8 से चेक कर लेंगे, देखेंगे आगे कितना बढ़ना है। पहले डिविजिबिलिटी बाय 4 चेक करते हैं, ठीक है। सो मेरे पास है, मैं सबसे आगे वाले पे चेक करता हूं, 3 raised to the power 2 raised to the power 2021, ठीक है। 3 की पावर है ना कुछ, तो 3 है मेरे पास, तो 3 को लिख दिया 4k minus 1 फॉर्म का, जैसे प्लस वाली फॉर्म होती है वैसे माइनस वाले भी होती है। सो मैंने इसको लिख दिया 4k minus 1 की पावर 2 की पावर 2021, राइट। ये तो एक इवन नंबर है, 2 की पावर समथिंग है, इवन ही आएगा। मतलब कि अगर मैं इसको मल्टीप्लाई करके देखूं, 4k minus 1 4k minus 1 4k minus 1 चलता जाएगा, यहां पे भी आएगा 4k minus, ठीक है, 4k minus 1। अब 4k minus 1 कितने टाइम्स है, कितने हैं ये, इवन नंबर ऑफ टाइम्स ही होगा। क्यों, क्योंकि मेरे को पता है 2 raised to the power 2021 इवन नंबर, इसीलिए मैंने सीधा लिख दिया इवन होगा, इवन टाइम्स पे, ठीक है। सो अगर आप देखो, -1 को -1 से मल्टीप्लाई किया, फिर -1 से किया, और इवन टाइम्स -1 को मल्टीप्लाई किया, तो ऑफ कोर्स प्लस बन जाएगा। और बाकी जगह पे 4k हर जगह मल्टीप्लाई होगा तो 4 तो आएगा ही आएगा, तो मैं इसको लिख लेता हूं 4l+1 फॉर्म। ठीक है, ये किसकी फॉर्म है? 3^2^2021 की फॉर्म है ये। पर मेरे को ये नहीं चाहिए, मेरे को चाहिए 3^2^2021 +1 की फॉर्म चाहिए। 4l+2 फॉर्म होगा। अब बोलो, क्या ये 4 से डिविजिबल होगा? नेवर बी डिविजिबल बाय 4। ये वाला तो नहीं हुआ। What about 3^2^20 +1? सेम ही होगा, 4l+2 फॉर्म का होगा, सो नॉट डिविजिबल बाय 4। सिमिलरली फॉर ऑल। सिमिलरली फॉर ऑल। ठीक है, तो मतलब कि ये सारी की सारी 4 की कहीं पे भी पावर नहीं आने वाली। ठीक है, तो हम लिख लेते हैं 2^1 इंटू 2^1 इंटू सो ऑन 2^1। ठीक है, यहां तक तो आ गया, जैसे मैं पीछे वाले में देख रहा हूं, देखो 2^1 2^1 2^1 2^1 2^1, लास्ट में आएगा एक 2^2 आएगी और एक 2^1 आएगी। ठीक है, अब ये तो मैं गिन सकता हूं कितने होंगे। ठीक है, देखो 1 2 3^2 से शुरू हुआ, फिर 2 पे गया टिल 2021 तक गया, ये हैं कितने? 2020 है ये। ठीक है, ये 2020 है 2s, और यहां पे 2s कितने हैं? 3 2s है। तो मतलब कि मेरे पास 2020 नहीं 20 है ना, गिन ले एक मिनट, 2021 भी इंक्लूड किया है और 1 भी इंक्लूड किया, 2022 होंगे, सॉरी 2021 होंगे, सॉरी 2021 होंगे। ठीक है, यहां पे करी गलती, क्योंकि फिर से एक बार देख लें, 1 2 3 19 टिल 2021 बोथ आर इंक्लूसिव, दिस हैज टू बी इंक्लूडेड, दिस हैज टू बी इंक्लूडेड, दोनों को इंक्लूड किया है, तो 2021 पर ही होगा, 2021 टाइम्स है और 2020 यहां पे 3 आ गया, तो ये 2s हैं कितने? 2024। ठीक है, अब बोलो इसके साथ जो भी बनेगा उसमें 2 तो नहीं होने वाला। ठीक है, क्योंकि मैंने 2s काउंट ही कर डाले। ठीक है, फिर इसके साथ बचेगा क्या? कोई भी एक ऑड नंबर बच जाएगा इसके साथ, सम ऑड नंबर। ठीक है, आई डोंट नो व्हाट ऑड नंबर विल बी, बट मेरे को उसकी फॉर्म पता है, 2m+1 फॉर्म का होगा ये। ठीक है, तो मतलब कि 3^2^2022, ठीक है, -1 को मैं लिख सकता हूं 2^, ठीक है, 2024 इंटू 2m+1, इस फॉर्म का ये नंबर होगा। ठीक है, इसको कंपेयर कर दो, ये भी मेरे को पता है, ये भी मेरे को पता है, तो 2^2024 2m+1 मेरे पास यहां पे था, विच विल बी इक्वल टू, डिवाइड किससे कर रहा हूं? 2025 इंटू सम कोशेंट प्लस 2^, ये मल्टीप्लाई हो रहा है तो मल्टीप्लाई कर दो, डिस्ट्रीब्यूटिव लगाओ, 2^2025 इंटू m प्लस 2^2024, यहां पे आ गया 2^2025 इंटू सम कोशेंट 2^, राइट। कंपैरिजन ही करना है, 2 की पावर है दोनों की दोनों, क्योंकि ये वाली साइड और ये वाली साइड तो इक्वल है। क्या आ गया? तो r की वैल्यू आ गई मेरे पास 2024। अब इसके बाद मेरे पास r आ गया, तो इनका डिजिट्स का स्क्वायर करके ऐड करना है, बस दैट्स इट। स्क्वायर करा और ऐड करा, तो यहां पे आ गया 4, यहां पे 0, यहां पे आ गया 4 और यहां पे आ गया 16, तो ये आ गया 20। ठीक है, तो अब ये वाला क्वेश्चन भी अगेन डिवीजन एल्गोरिदम एंड नंबर थ्योरी मिक्स था, इसके अंदर डिवीजन एल्गोरिदम लग रहा था, नंबर थ्योरी का बेसिक क्वेश्चन। ठीक है, होना चाहिए था, बट स्टेप्स थे इसमें, मल्टीपल चीजें देखनी थी, तभी बोला है 5 मार्कर क्वेश्चंस को अगर आप पार्ट्स में तोड़ोगे तो निकलेगा, नहीं तो निकलेगा। ठीक है,